Yeah, it was addressed.
Okay. Hello, hello. All right, folks, we're going to go ahead and get things started. Pipe down. Hey, hey, hey. We're starting. Thank you.
1, 2, 3.
Okay. So, welcome to Planet Nix. This is day 2. So I have the schedule up here. This is on Sessionize. This is correct because we're starting on time today. Yeah. We got there eventually. So just to run through some of the same things we said yesterday in case there's any newcomers. We have some social accounts. Any announcements that we have will go out through there. So any scheduling adjustments, stuff like that. Use a Planet Nix hashtag. Rooms. So this room is all talks. The room over there, 104, is primarily workshops. There might be a couple talks throughout the day there. I have a meeting that I'm supposed to be in. Yeah, there's all the congregation space out there as well. That's totally free to use. Congregate, gather, be nerds together. That's what we're here for. Tables. So there's tables out there as well for community projects. You can either talk to the maintainers or find something to contribute to, whatever the case may be. That was yesterday. We're not doing that today. That was also yesterday. We're not doing that today. Instead of lightning talks, today has what we call an unconference. So what that is basically an hour for us to self-organize, talking about whatever we want to talk about. So kind of the format for that is we'll have a whiteboard up here. We'll have a short period of time where everybody can come write up a topic that they want to talk about, like as a group with whoever else wants to talk about it. We'll have a short voting period so people can show which things they're interested in. And we'll just take the most popular ones and split off into small groups to talk about those things. It can be literally anything that you want. You want to talk about keyboards? You can do that, okay? Yeah, so there's a lot of people that made this happen. They're all in this list. We thanked them yesterday. We're going to thank them today. I'm one of them, so I'm not going to read my own name. Yeah, so thank you to all the volunteers and the SCaLE team that make this possible. It literally is not possible without a bunch of volunteers. So, yes. Ron, do you want to talk about nerd stuff? Journey into Planet Nix?
No, we talked about that.
Okay, cool. Nerd. I don't know what that was about.
Flakes?
No, the same joke as yesterday. No, wrong. Yeah, Ron, take it away.
So one of the things we really want to make sure we do, and I think it's, when you have a really great technology, that's only part of the equation. The other part of the equation is how do we talk to people about it. So we have an awesome trio here in the front. I don't know if everyone had a chance to meet them, but I'm going to give them a second to just introduce because they have way more better things to say than I do.
Well, hello, everybody. I'm Chris from the Linux Unplugged podcast. Hi. And you'll see myself, Brent, and Wes here. We'll be going around, and we're looking for Nix stories. Yeah, buddy. We're looking for, so if you have a Nix story you want to share with us, or particularly Nix at work, we're really focused on this trip, grab us. We'll have a microphone. And then be sure you check out Linux Unplugged after this, because we'll have Planet Nix coverage. We actually have a lot of Nix coverage in the podcast if you haven't checked it out yet. It's kind of a problem, but it won't be a problem for you guys. But all the non-Nix listeners, it's kind of a problem. Yeah, we might as well call it Nix Unplugged. That's fair. That's totally fair. So come say hi to us. If you've got a Nix story, please share it with us. And then afterwards, check out linuxunplugged.com. Oh, yeah, thank you. And then Saturday evening, 7 p.m. at the El Chico Mexican restaurant, we have a meetup, and you're all invited, of course. We'd love to say hi and chat Nix, because it's our excuse to chat Nix while we're all here. So, nice to meet you all. Check out the show.
Awesome. All right, and with that, have a really good day. Quick reminder, tomorrow is SCaLE. There's going to be a Nix booth. If there are folks who want to volunteer at that Nix booth, come find me, come find Ross, who just went out. Tell us. We'd love to have more volunteers out there, talk the good word on Nix stuff. Other than that, have a good second day, and let's get started.
on that? Mirror.
Mirror. There we go. Now if I do that. Okay,
Yep.
cool. You'll give me some time warning? Like,
Yeah.
okay. The 10 and the 5.
All right. Let me go ahead and read you in.
There will not be time for questions at the end, just to let you know.
Whatever. Okay. All right, folks. We're going to go ahead and get started on the first talk for the day. This is Michael Stonke, my boss. Flox as a guided path for Nix.
All right. The most difficult part of giving this talk is they want me to stay on this little stage, and that is not how I roll. So if I apologize to those watching on the internet, I will not be in frame at times. All right, I'm going to talk about Flox as a guided path for Nix, and I'm going to be the first one to say that I do not know a ton about Nix, but I do know a lot about Flox, and I've run engineering there, I've run product there for a little bit. It's awesome. I'm having a great time learning more about it, but I'm going to talk about some of the warts we've uncovered and some of the things that, as a newer user of Nix, that I've found interesting. We'll say that. So, first thing is, this is not a sales pitch for Flox. As much as Ron would love this to be a sales pitch for Flox, it is not. It's about thoughts and approach. I am really talking about the reasons and the why that we've built Flox and what we've done for it and how we think about the process. And a lot of this is other people's thoughts that I'm collecting and aggregating and resharing with you. These are not solely my ideas. A bit about me, I used to have hair, and I used to have a really long beard. And neither of these things are true anymore, but I still like the drawing, so I use it often. I worked at Caterpillar, Puppet, SCaLE, and now at Flox. So I'll talk a little bit about some of these experiences. I also wrote a book called Pro Open SSH like 20 years ago at this point. Wow, that's a long time. And I founded this Apple repository. If you ever used RHEL or CentOS, I was one of the people that created that. Yeah. So, and the reason I did that. Anyway, yeah, thanks. I haven't been involved with it for a few years, but it was a really great time. The reason I did that primarily was I wanted a bunch of Ruby stuff in Apple because I was a big Puppet user. So like it was self-serving all the way through. But as part of that, I went to go work at Puppet, and then I was working on packaging a ton. And so I have packaged for basically every operating system that is Unix-like that has ever existed, and some you've never heard of. And it's not that it's this big problem, but the point is, I guess, I'm not a newbie to packaging at all. And when I got to this Nix thing, I was like, why does this feel so foreign to me? So that's going to be some of the theme of some of this. So for 15 years, I've basically been doing infrastructure development and developer tooling vendors between SCaLE, Puppet, and now Flox. But when I first saw Nix, I read the paper when it first came out, or shortly after it first came out. How did that happen? Wow. Okay. And what I really thought was, okay, so some Haskell people decided package management was just too simple, and they needed to change it. That was basically my impression of what I saw when I read the Nix paper. And it just didn't make sense to me, and I was like, okay, it needs a new language, fine, whatever. And then my FHS was gone, and I know a lot about FHS because if you've ever been a maintainer for Fedora or RHEL or Debian or whatever, it's just first principle. You have to know everything about FHS, and if you violate it in any way, your package gets rejected and you get told you're terrible at life. So I learned a little bit about Nix, and I was like, okay, I don't understand a lot of this. It seems really weird. It's foreign to me in every way. I didn't look at it again for years. But at Puppet, I did packaging all these things. We wrote our own tooling. We built our own CI system. The next time I saw Nix, I was at SCaLE. So I had done all this packaging and all this other stuff, and I was at SCaLE, and I had a team that was focused on developer enablement. Yeah, I really cannot stand still. Okay. I was focused on developer enablement, and the things that mattered were how fast can we get the next team online and to work on this service. When you have 200 plus microservices and 30 teams, people are jumping around a lot into different services, and so how do they get started? We found some consistencies able to use Nix, and there were some teams that were like, this is great, I love this, and there were other teams that said, what are you doing to me? I am never going to touch this. This hurts too much. Okay, well, eventually Flox kind of pings me, and they're like, hey, we're looking for a leader for engineering. We think your background's really interesting, and I was like, okay, and so I love developer productivity package. I love tooling. I love packaging. I was like, let's check it out. Let's go do this Nix thing. So I'm a new Nix user. my first thought is, why is this so complicated? I have all these things that are like purity and shell and flakes and closure, and not closure, because I was more familiar with closure than I was with closures. And then store path, derivations, profiles, expressions. Oh, familiar with closure does not mean I liked it, by the way. But there was all these new things to learn that were just words that didn't map in my brain to anything else. When I said, how do you install a package, the answer I got was, what do you mean by install? And my response was, what do you mean, what do I mean? I'm asking to install a piece of software. And they're like, well, do you want to be able to use it? No, I just want to eat up some disk space. Like, what? Okay. So there was a lot of stuff, there were other problems like, okay, I couldn't find headers if I installed things a certain way, or I couldn't find a library. There was like the shell and there was a develop, but they weren't the same thing, but they felt really similar. And there was these experimental features, like being able to use a space. So it was really weird. Commands with spaces require extra arguments to say, yes, I want to be able to run commands with spaces. And I know a lot of you are thinking, but the reasons are valid. The outcome is ridiculous. Because as a new user, I have to say every time I want to use a thing that has a space in it, oh, enable experimental features. And they're like, well, you just go edit your nix.conf. You know what? Somebody has to tell you to do that. And why do I need to enable experimental features just to have a command with a space in it that, as far as I can tell, does the exact same thing as the command without the space in it in like 90% of cases. So anyway, weird thing. So the other thing is you start with your build and then you write code. And I'm a release engineer by trade. Builds are my jam. This is awesome. What are we doing? We're starting with a build? Building what? Let me define my build. I'm going to define all the dependencies that I have. For what? I haven't written any software. It doesn't matter. Start with your build. Okay. Nix is weird, man. So Nix basically is like, hey, would you just like to start in the deep end? And the answer for me was, I felt like I was a really good swimmer already. I felt like I was basically like at the Olympic level. I packaged for AIX and Solaris and HPUX and every Linux. Like I've done Yocto distributions from the ground up. I can tell you the scars of how Cisco's Nexus line is built internally. Like it is so much junk. And I was like, okay, they called it swimming. It's not swimming. This is like the people that train for triathlons by attaching the bicycle to their back and then jumping into the water. It was like that. So, all right, so let's take a step back. What is Nix awesome at, though? Because Nix has some really, really cool stuff going on. I've got reproducibility. That's pretty cool. We worked really hard on that on some different Linux distributions. And if you ever watched the Debian guide of how to get reproducibility through, they did a lot of really cool stuff. It probably helped the Nix upstream in a lot of ways. But man, was it painful. Cross-platform stuff, always awesome. Trying out new software. I love to try out new software all the time. So that's really cool. Caching builds and tests. Okay, now you're piquing my interest. As somebody who worked at a CI company, anytime you can cache things and skip tests, life is awesome. And this huge, huge package repository. But the problem with Nix was it basically started with, you must unlearn what you have learned. Now the problem is I've heard this somewhere before, and I really didn't like where it ended up and where it took me. And so I'm going to go on a little bit of a tangent here. I'll get back in the camera frame for a minute. But this is the CNCF. That's just the infrastructure. That's just the platform section of the CNCF. So there's a lot going on here. And this was I have to unlearn what I have learned. And then you have to overcome all of the deficiencies or the inaccuracies or the incompleteness of different parts of the CNCF landscape by getting more parts of the CNCF landscape in your tooling. So basically, every time you have a new problem, you solve it with another layer. And every time that layer introduces a new problem, the only thing you can do is introduce another layer. And so now we're just turtles all the way down through CNCF tools. And you end up with microservices that look something like this. I'm not going to say that I pulled that directly from a place I used to work, but I'm going to say that I may have. And so you have all these services, and then you're like, hey, that's the thing that's broken. Cool. How do you find that? It's really, really, really hard. Distributed debugging is the hardest thing in the world, and you can go back to these original Kernighan and Rishi, kind kind of quotes, but basically, if debugging takes a better brain than it does to author it, don't ever write clever code because you won't be able to figure anything out. That's more or less what it says. So, why did I go off on that tangent? I'm going to come back to that in a second. I have a desire for simplicity. Fewer choices lead to better outcomes. I have a desire for Nix benefits. Cool, cool, all right. I want simple Nix, I think is what I'm going for here. I have a desire for cross-platform work. Okay, that's cool. So we want workflows where a developer can have a way to contribute to a project, usually locally. Because what I've found is I've tried to build out things that look like dev containers or remote cloud environments for developers or whatever. I've tried to do that 4 different times at different companies. Developers will resist you every step of the way when you take away their ability to develop on their laptop. I know you can say, hey, I do it all the time without it. Cool, do you like it? Because what I've found is they don't. And I tried really, really hard with different solutions. So anyway, they want things locally. Set environment variables in some way, configure the environment, run some tests, you know, basically use their editor, use their preferences. They want it to feel like home. They want it to feel like their computer while they're doing their development. That's a really cool thing. But I had to unlearn what I have learned. But why do I have to do that? We've done a lot in the last 20 years doing cloud-native tech, cloud-native architecture. There are a lot of really cool tools that have come out. And I'll dog on Kubernetes all day because I think it's overly complex and most people don't have problems that it actually addresses. But we've all landed there, okay? Cool. What have we learned? What can we take away from all of these infrastructure and cloud tools? Quite a bit. But at the same time, there was this other parallel track of technology going through that was called Nix. And what have we learned doing that in the last 20 years? Okay, can I combine those together? Can I combine those without abandoning all the existing knowledge? Can I debug using strace? So anyway, the thing is with cloud native architecture, we've also thrown away some of the things that were awesome about Unix and about Linux and about these other ways of operating systems. Multi-user is a thing that has more or less died in a cloud native world. All these systems are there to one process or one container under one thing. We're not doing process quotas. We're not having hundreds and hundreds of users having terminals on these things anymore. And those are powerful, powerful systems that we just basically walked away from and saying that was too difficult, so we're just going to spin up N of them with a single tenant on them in a lot of cases. We don't debug using shell. We launched debug pods and debug tooling. Heck, there's a whole industry that you will see at the Expo Hall or if you're at reInvent or KubeCon or whatever of just people telling you how to debug things in cloud native world. It's a hard problem. I get why it's there. But what if we just didn't have the problem instead of having all the tools to solve the problem? And process and user accounting. So I have all these things. I added complexity when I do cloud native because now I also get into IAM as a really hard problem, a really fun problem. And then I'm just, paying for monitoring services that monitor my other monitoring services that monitor my other monitoring services so I can make sure it's all good. And just to add insult to injury, you also have to use YAML to do all those things. So there's a lot to like about cloud native architecture. There's a lot not to like about it. But there's a lot to like about traditional Unix and Linux concepts. And these are the things that these were established in like the 70s and they're still awesome today. And I think that is remarkable for whoever designed these systems. But why are they mutually exclusive? So let's build upon the power of Nix. I want a simplicity of an environment that you can work on in your shell. Okay. I want to be able to search and install packages. And I will say that my experience with Nix search was a little weird. There was like a lowercase I and an uppercase A, and I had to have Nix packages with like a hash in there to go say this is what I want to search. All of that felt very weird to me when I could just do yum search package name or apt cache package name or brew search package name or, go on and on and on and on and on. It was nothing like these. I just wanted to install things. And I wanted install to do exactly what I thought it meant when I say install. It meant I want to be able to have the bits on disk, be able to run the bits on disk, or look at the bits on disk from other places if it was like a library or whatever. I didn't think this was controversial. I want specific versions of packages to be available. This was what I kept hearing about Nix was it's a continuous release, and so they have all these things, and I was like, cool, how do I get an old version? And they're like, well, do you like git bisect? And I was like, actually, I do like git bisect. That's awesome. And then they were like, cool, no one else does. And I was like, oh yeah, that's right. So And what I was looking for also was just this idea of no variance. Like if it works on my computer, I want it to work on yours. And I don't just mean that from a meme perspective. I mean like if I want to actually contribute to this project and I want my buddy to contribute to this project, it shouldn't be, oh, well, I set it up this way, but you have to set it up this other way because you're on Ubuntu and I'm on a Mac. Like that's just not great. So what I wanted the workflow to be, what I felt like was going to work the best from everybody I'd ever talked to in life that had never heard of Nix was I want to develop some software, then build it, and then operate it. Cool, we called that an SDLC when I was in computer science class. So the other thing I wanted to be able to do was I want you to be able to do partial SDLC adoption for the tooling. Because if you do the whole thing, it's just such a big lift, you just don't move. I need to be able to meet you where you are. So starting with the build is a super unfamiliar thing. And that's kind of where Nix starts. You start with your definition, you have a Nix file there, here's how I would build this project or whatever. That's a little weird. I wanted a thing that I could share how I worked with my colleagues, you know, like with production. I could share it from development to production. I could share it with my colleagues. I could share it with my friends, coworkers, strangers, children, others. And so as we were making Flox, one of the main things we were thinking about was how do I make this learning curve not feel like I just jumped into the deep end of the pool? It's not to say that we wanted to make Nix with training wheels. It's not. We wanted to build upon the power of Nix and do something a little different. But our goal here was to make it easier to level up than to just be like, I don't know what I'm doing, don't know what I'm doing. I have to learn everything and now I'm awesome. We were like, okay, let's learn a little bit, learn a little bit, learn a bit. Okay, you're happy now. And I think that's okay. So our complexity here was if you know Nix, great. We want to help you with that. Perhaps this can help you get Nix into your company or into you know, the projects you're working on. What we found talking to a bunch of Nix users and Nix advocates was if you ran Nix in a company, in almost all cases, there was one, possibly two, if you were extremely lucky, people that could make changes to that system and drive it through the business. And that meant that Nix adoption didn't happen in a lot of cases inside of companies. As a leader, I would have never allowed that to come through. If there was exactly one person that could make changes to a system, heck no. That is a risk that is unacceptable. So we had to make sure that that risk profile could change significantly. What we have found is that with Flox, a lot of people that love Nix can now still use all their Nix tooling, and they love it, but they can also get their colleagues to use Flox tooling, and they're happy. And we've met in the middle. Excellent. So if you're new to Nix, I would really hope that Flox would be an easier approach because it should feel more like a traditional package manager that you've used. It should feel a lot more like a virtual environment manager that you've probably used before, whether it was Python, Ruby, Node, whatever. And that we want the modern SDLC, they actually want the properties of Nix. You've seen people go out of their way to do things with Docker containers that mimic reproducibility that is child's play next to what Nix can do. You've seen them do workflows of, hey, we can share this, it works on your computer, it works on mine, until you realize that one person's on an ARM chip and the other one's on x86, and then you're like, oh, that actually doesn't work as cross-platform as I wish it did. But there's all these Nix benefits, and so I just keep coming back to this. Gosh, I want these in people's hands. Well, Flox, we centered around environments. Our unit of work throughout the entire system is this thing called a Flox environment. And an environment is a collection of packages, environment variables, hooks, and services, so it can feel a little bit kind of like Docker Compose. It can feel like I can share this environment with you. If you're on a Mac and I'm on Linux and I'm on x86 and you're on ARM, great. At install time, we figure all of that out when we're creating the environment. So we know the environment works everywhere. They're shareable, they're portable, they're built upon Nix. It's really, really cool, but they're not one-to-one Nix. Nix is a supply chain. It is underneath the way we're working. We are not trying to build Super Nix. We're not trying to build Nix++. We're not trying to say we're a better version of Nix. No, we're trying to solve SDLC problems while building upon Nix. Our goal and our approach is really to meet the technologists where they're at. And I was going to put developers at first, and then I realized that the SDLC has a lot of components that are not solely focused on developers. If you want to start with using Flox environments in production and in operations for tooling, go for it. We got no problem with that. You want to start in development? That's fine. You want to start in CI? That's fine. We'll meet you where you're at. And then the developer experience is paramount. We want to make sure that developer tools feel good when you use them. I've used so many developer tools in my career. And the bar for good usability in developer tools is lower than this stage I'm standing on. So we think we can be better than that by a lot. That's really what I have to say about the way that Flox has approached things. We're trying to change the user experience. We're trying to change the approachability because of the way that we've not starting with build and we're actually starting with this traditional SDLC workflow. We have environments that are things that are portable through. And what I'm not going to do is run you through a demo and everything else like that because I'd rather actually have a conversation with you in a more detailed way if that's what you want. And if you do, there's a booth out in the hall. We'll also have a booth over at SCaLE at the expo. We are happy to talk Flox or Nix all day. I have wonderful colleagues over here, over here, over here, over here. You can find anybody. If you see them with a Flox shirt on, they can probably help you. But just, I want to say thanks. You know, this community has been an interesting one to be a part of. My first experience with a Nix person at Darmstadt was I said, hey, this Nix package manager looks pretty cool. And they said, I'm going to stop you right there. Nix is not a package manager. And I got told why I was wrong for 35 minutes. So that was not the most welcoming introduction to the Nix community. Since then, it's been a lot better. And so I really appreciated the messaging yesterday from Kelsey and others saying, what are you doing to make this community welcoming and open? And I really want you to think about that. This community is awesome, and it can be awesome, but it's made up of people like you. So just be awesome to each other. All right, thanks. Okay. All right. Zach says I have time for questions. If anybody has one, feel free. The question is Flox on Windows. We are really good at the WSL2 part of Windows. The rest of Windows, we have the same concerns that Nix would have on Windows. There is a developer really working on Windows Nix, if you're ever curious. He has a blog. It's really interesting to read. Yes. Oh, their question was, runtime dependencies and build time dependencies are two separate things in Nix. Do you plan to support that at all? Absolutely. There are different ways of doing different things, but yeah, we understand that you do not want, you know, an 800 megabyte closure if you're just going to run something at the end. So, well, yeah. All right, well, thanks so much. Did I actually see that? I was more talking about ideas.
just like.
Actually, I'd prefer if you use this. Oh, really? Okay. Yeah. Yeah, let's turn this one off real quick.
Check, 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 check.
All right, everybody, it's time for the next talk. Up next, we have Morgan Jones with Adventures in Mesh Networking with NixOS. So everybody take a seat, and we'll go ahead and get started.
Sweet, thank you. Check, check. All right. Cool. So yeah, this talk is Adventures in Mesh Networking with NixOS. Kind of describing my experiences with a few friends from college at basically DEF CON over the past few years using NixOS as a mesh router. So, just some info about me. My name is Morgan. I go by Numinit on the GitHub. I maintain things like Android packages and a few of the theorem provers and some amateur radio packages and mesh VPN packages, things like that. So I've been playing with Linux since like middle school. My first Linux machine was an Action Tech DSL modem in like 2005 or something. I think it was kernel 2.4, if not slightly earlier. It had a nice, minimal BusyBox instance, not really that fancy. Eventually turned it into a career, got a CS degree with a focus in embedded security from Rice University. In 2017, I found Nix after a good friend from college got me into it. I ended up in college running an art installation in 2015. They used 10 Raspberry Pis, and I deployed them with Arch Linux and shell scripts, which left a lot to be desired. I was booting them with U-boot. I had to deal with, generating the U-boot config every time I wanted to redeploy them. It was kind of a pain. Needed a better way, so found Nix, and I was like, oh, why the heck didn't I, just use this instead of literally anything else? So also discovered that Nix was very useful for kind of strange multi-node embedded security and network applications. If you can deploy the same software on every single device, then, well, you can just stamp out 10 Raspberry Pis really quickly with a Nix config instead of needing to individually attend to them with some other deployment method. So I use Nix. I work at Viasat in Carlsbad for DevOps, build pipelines, system building, that sort of thing. That being said, this talk was for fun. So this talk is also from a future. Not the future necessarily, but a future. It's 5,016 years right now after the founding of Union. Humanity has spread throughout the galaxy. Some people travel between worlds, taking jobs that no one else will, and they are known as Lancers. Let's talk about Lancer. So Lancer is a tabletop RPG. It's a role-playing game set 17,000 years in the far future in the Milky Way galaxy populated by humans. This is a mech, basically, which you pilot in Lancer. It's pretty fun. If simulated mech combat is your jam, I highly recommend Lancer. It's a very kind of numerically crunchy system. That is very fun combat. And Notably, it's the only tabletop RPG I've ever seen where players actually specified how the internet in it works. In the year 17,000, some players came up with some kind of in-world hooks for how the internet works. And the gist is that you actually have sub 100 millisecond latency between any 2 points in the Milky Way galaxy, which that would be pretty cool. It's a lot more than that today, even to get to high Earth orbit. But so what if we could, instantly communicate across the galaxy? This is a screenshot from CompCon, which is Lancer's character sheet builder. And what you'll notice is, according to Lancer, first of all, you call it the OmniNet instead of the internet. So, just first of all, rename it to something that makes a little bit more sense. You'd obviously be able to get software on your ships and mechs from literally anywhere. According to the official character sheet builder for Lancer, there are still Unix paths, there are still man pages. Like Linux has clearly, survived the year 17,000 or whatever. And also there's still a hierarchical RCU implementation when you're booting the kernel. It just displays that on your mech every time in message. So Linux has survived 17,000 years, so clearly it was built to last. Obviously everyone's mechs would be running NixOS. And Pluto's a planet again, because obviously if everyone's mechs are running NixOS, people have a newfound respect for Pluto. Yeah. Hooray for Pluto. All right, so fundamentally though, the network topology might start to resemble a mesh. If you can communicate between any 2 points in the galaxy instantly, you can start linking with people who are nearby you. So if you're physically near someone, then that's your layer 2, basically. So that's the link layer in the OSI model. And you can route to others who aren't nearby you. So, if you're transmitting, a message maybe between the solar system and, some other thing, like the Karakin trade baronies or something like that, you can route it through someone else and relay through, they have like this in Lancer, some strange subspace relay thing, but obviously it's fiction, so. And really what you want to do is you want to use it for something interesting. So in Lancer, that's saving the galaxy. For us, maybe we can just download another copy of Chromium or TextLive or something and fill up the Nix store and, I don't know, maybe use that software. So let's talk about a mesh VPN called Nebula. So I maintain Nebula and Nix packages. 2021, Tim and I both got tired of Tink. So Tink's a mesh VPN too. That I used to use on FreeBSD prior to getting into NixOS for networking stuff. Tink is notoriously single-threaded. There's a NixOS module for it, but what I wanted to do over Mesh VPN at that time was do ZFS backups over it. So send entire deltas of ZFS datasets to another server for offsite backups. And so we wrote the NixOS module for Nebula VPN, and its PR number is 111,518. So Nebula is a mesh VPN. It's actually written in Go. Slack wrote it, and it's based on the noise protocol. So noise is it's a cryptographic protocol that specifies things like handshakes, and fundamentally how noise works is it uses AES GCM once the two sides agree on a key, and then because GCM is integrity checked, people can use that to communicate securely. Finally, we're able to get good performance and multiple threads because it's written in Go. I started running it for kind of personal networks, regular ZFS backups over it, trying to avoid exposing things like SSH to the internet, and having this kind of overlay mesh network that connects computers in different parts of the country with some VPSs I have, and very nice. You see the modern, I guess a newer version of this is like Tailscale or Headscale or something like that. But yeah, Nebula was one of the first. 2022, Chris, Andrew, me, and a couple more friends started testing Nebula on NixOS machines at DEF CON 30. There are very good results, basically. DEF CON is it's a hacker conference, obviously, in Vegas. People should go every year. Very good results. We used it mostly because, alternatives were WireGuard, but our thought was, well, if we want to bring friends, we want to get them on our mesh network, and we want to get them, securely routing all of their internet traffic through Nebula, so, they can get out of the Vegas Convention Center where thousands of people are scanning networks with Wireshark and things like that. So we have very good results. The speed was really good. Reliability was actually outstanding. And we had very little in the way of actual speed decrease with it, other than moving kind of where the exit traffic was from to a VPS. Continued testing at DEF CON 31 in 2023. And so this is where things got a little bit gnarly. So the internet went down at the convention. And by down, I mean like people couldn't get, upwards of 128K up or down. It was kind of a mess. And, well, we had a bit of a hard time substituting from cache.nixos.org without, any bandwidth. So we kind of started questioning our life choices, asking some deeper questions about binary cache costs, and started going, well, okay, so let's say you can't get to cache.nixos.org. Like, what do you do? How do you solve this problem? How do you, get people on networks securely? Sort of things like that. So kind of we had retrospectives after each one of these years that we ran our VPN set up at DEF CON. So 21 had like a little router running OpenWRT and Ethernet cables in my backpack. Managed to get Nebula on the little OpenWRT router. It worked okay. 2020 internet connection barely worked at all. And we started having some trouble. The setup is, well, cache is gone, NixOS. This is what was there. The constant need to copy Nix closures are way too demanding on the terrible networks at DEF CON. The challenge for next year will be running Nix binary caches much closer to us. An Edge CDN in a backpack is a new challenge for DC32. And also DC31 ops were an extremely solid iteration over DC30. See you at 32. Let's push Nix binary caching to its limit. So this turns out to be effectively a maximally, is this working? Oh, keep going, okay. This ends up being a really hard distributed systems problem. So how do we distribute internet connectivity and the binary cache to our laptops in the convention center? We go around with like flippers with things where they can just knock people off Wi-Fi networks. So how do we ensure that things stay up even when people are being maximally adversarial? And also, how do we avoid getting our traffic sniffed by hundreds of people running Wireshark and Kismet and things like that? And how do we trust also that the derivations that we're substituting when we need to go out to a binary cache, even if we can't get to cache.nixos.org, are legitimate? So layer one basically is reliable hardware. So it's actually in this backpack down here. I'll have it after the talk. But so this is the Protectly VP2420 as our kind of compute, basically. The specs, it's got a Celeron, 16 gigs of RAM, some 2.5 gig Ethernet ports, USB, and a TPM, and a huge battery pack that you can buy. Protectly is actually based out of Vista, so they're like 10 minutes away from my house, actually, and they donated all this hardware. Also, just a shout out to them for their engineering team. They kind of tested to make sure that the battery would last all day, and that we weren't doing anything super unreasonable with the hardware, even it being in a backpack all day. So for the mesh, we used 5 gigahertz Wi-Fi. We talked about doing 6 gigahertz, but we couldn't find a 6 gigahertz chipset that worked well with MeshPoint. We used the MT76 chipset. It's a MediaTek chipset that it's a really nice chipset, actually. It supports Maunder mode, a bunch of the newer Wi-Fi standards, and critically MeshPoint. For external, you can get this. There's this Panda Wireless PAU09. I've got a handful of them in there. Internal, there's an Asia RF MT7612, which is an M2 module. More on that in a second. There's actually a cellular modem in this. So there's an AMET MDG200. It's a Quectel, basically, 4G modem for each mesh node to get out over 4G. And for the binary cache, we can shove a Samsung 840 EVO in there, basically, and use it as a cache. And the root is on internal eMMC. Also, more antennas, so we can do Wi-Fi client, we can do Wi-Fi monitoring, and basically just stack this thing up with antennas. So layer 2, or actually, here's a picture. So this is kind of a crude drawing. So there's a mesh. This is the only picture of this I could find that was annotated, actually. Mesh Wi-Fi is on the left, the WWAN's on the middle, and the TPM is on the top right. The mesh, notably, Asia RF sold 2 versions of this basically MT76 chip. The one that I got needed a M2 B to E key transposer board that I had to pick up from Amazon and actually Dremel the board to get it to fit. Pro tip: if you're dremeling PCBs, always do it next to a fume extractor and wear a mask because you don't want fiberglass everywhere. So also one of the things I'll point out is these little IPEX antenna connectors. They're super easy to break, and they're really, really easy to get the wrong size. And they're also easy if you get the wrong size to think it's the right size and accidentally force it in and break the connector. So yeah, and antenna connectors are fraught with peril. So also, I'd like to point out, so Protectly is actually sponsoring mesh research for hardened BSD too. So they're collaborating for mesh network stuff in hardened BSD. Yeah, specifically making censorship and surveillance resistant mesh networks with actually very similar devices to these. So all right, let's talk about standards now. So we've talked about hardware. We picked this hardware just based on compatibility with stuff. So layer 2, Batman running over 802.11s encrypted with WPA3 SAE with 802.11w management frame protection. So it's a lot of acronyms. Let's break it down. So Batman is a Linux layer 2 mesh routing algorithm. So this is actually, it's a kernel module that you can load. And what it does is it uses something called the echolocation protocol to figure out nearby mesh nodes. So you can actually run Batman over any link. So any layer 2 Ethernet connect. You can even do it through Ethernet. You can do obviously Wi-Fi with this. But what it'll do is echolocation protocol will periodically basically ping out requests to everything around it. And then everything around that node will reply. And it uses these basically as a form of distributed ARP. And it literally will maintain a distributed ARP hash table among all the nodes that it knows about for figuring out which addresses correspond to which physical addresses. So 802.11s is a Wi-Fi standard called MeshPoint. Basically how it works, it's conceptually really simple. So if you're near another Wi-Fi access point with the same SSID and key that also supports MeshPoint node, they'll automatically connect. And as opposed to an infrastructure network where you're connecting to an access point or it's kind of more of an ad hoc network, except that it's an ad hoc network with arbitrary numbers of nodes, and no one is really a server, or rather an access point. It's really everyone's an access point. WPA3 SAE, so this is the new WPA3, or newer WPA3 standards. Basically, it's encrypted. Also, you get perfect forward secrecy. So that means you can't retroactively decrypt traffic. So if you capture someone's packets and they're WPA3 SAE encrypted, even if you know the key, you can only decrypt packets effectively for the current session. And you can't go back to previous sessions and decrypt those, basically. And then there's 802.11w. Basically, people can't deauth spam you. So it's management frame protection, so there's a bunch of frames basically that are used for management, and this basically ensures that only valid management frames can be received if you know the key, basically. So the network's actually up in this room. Here's a challenge for you guys. You guys can take a picture of this. Connect to NixMesh is the SSID with the same password that we use at DEF CON, and that's the password. Well, rather, that's the pre-image of the password. I'll leave that on the screen for about 10 more seconds. All right. So more standards. So for layer 3, so this is the IP layer, Nebula VPN, based on the noise protocol. So this is how each node gets out to the internet. So if you're in a convention center like this one, obviously you have an uplink. And yeah, this was basically how we got out without, assuming someone's in the middle of, between us and the internet, basically. This is how each node gets out. So authentication actually is done via a standard called PKCS 11. So this developer, Jack Doan at Rivian, actually was adding PKCS 11 support to Nebula literally like a month and a half before DEF CON. I think he was actually going to the car hacking village, and I don't know what they're using Nebula for at Rivian. But he was adding strong authentication with hardware key stores to it, and I mean that's really cool because I'd already written this tool called NixPKCS, which can automatically and declaratively generate keys in hardware key stores, and I was kind of looking for a use for the TPM, and it was like, holy crap, perfect. So this is NixPKCS. It's been out a while. This is more, I would consider this more production ready. Yeah, basically I added support for Nebula signing certificates from PKCS 11 keys. Because signing and key agreement are different, basically. So now you could store CA certs or rather CA keys in like a YubiKey or something, and keep that offline and sign Nebula certificates, by plugging a YubiKey in or something. Also, there are tests for this in NixPKCS. Make sure that you can set up a Nebula network this way. So here's a picture of a couple of the nodes. This is from, there's a sticker actually on this from Snug that's, I'd rather be working on my Nix config. A couple other nodes next to it, but yeah, you can see that there's a kind of large battery pack beneath that. That's the extended battery pack for these units, basically. So the big question is, what do we do about the binary cache? So this is kind of where we knew things might fall apart because few have actually done this successfully. So our goal was basically to figure out where it broke. And if you really want to do distributed binary caching, what help do tools need? So the first thing we tried is NixServe or NixServe NG. So turns out this actually, we had some trouble with NixServe, even behind Nginx, because it actually replaces the signature from Hydra if you provide a private key. Provided if you don't provide a private key, then it won't replace the signature. But actually, NixServe NG has the same problem. So here's just a snippet of the Perl behind this. Basically, if the secret key is defined, then it takes the nar info and basically re-signs it and appends the signature. Otherwise, if signatures are defined, then it will just print, add the signatures to the nar info that are there. So all right, well, if we really want to try this, so let's say we fix the issue with, or we don't provide a key or something like that. So it just passes through the key from Hydra. Well, here's how you have nix.conf keep going, actually, if one mesh node fails to connect. You tell it to use substitutes, you tell it to keep going, you give it a low number of download attempts, a low connect timeout, tell it to fall back, and give it all your substituters. So the problem with this is that if you get a lot of timeouts, like say another mesh node goes away, you get this head of line blocking, basically. So it will, if 10.32.0.1 is down, then it will wait prior to trying 10.32.0.2, and that's kind of an issue. It makes the UX really slow for downloading things, and yeah. So if all mesh nodes are visible, however, it actually works pretty well. So if you have a setup where you have multiple mesh nodes that are kind of always going to be up, they're always sitting in different rooms of your house or something, you totally can do substitution over mesh, which is kind of cool. Well, so are there any other options? Well, there's got to be a better way. So here's another option that actually is fairly recent. It's called the Nix Cache Proxy Server, which is written in Go. And actually, this worked pretty well. This is in unstable. It's services.ncps. It required a patch that I had to submit. Basically, the patch was it queries Nix cache info on startup. So there's a magic kind of Nix cache info URL on cache servers that it asks for, basically, to retrieve the priority of that cache. Really, this is something that should be configured if you're doing a mesh on the actual mesh nodes. So it's just trying to grab the priority. We can actually specify that like Nix does, so I submitted a PR, and that solved the problem. Instead of replacing the signature, it also appends a signature. So this is kind of problematic for a different reason. Basically, what does this signature mean? So if we sign a package twice, are we signing it, that we built it on one signature, or that we just cached it on this other signature? Given that Nix only checks for one, what does adding another signature mean here? So kind of long term, basically, if we don't trust signatures other than Hydra, it works fine. We can still just trust Hydra. But this definitely works pretty well, and NCPS it seems to be written pretty nicely in a way where it will try different caches and fall back, and even race multiple caches possibly. So this seemed like a pretty good option. So here's some just recommendations for this going forward. So if you're implementing a cache client, so if you want people to be able to use your cache client in mesh topologies. So first of all, please be lazy with loading Nix cache info. So don't try to do it eagerly and find all the information about the cache right away. Do it when people request nar info from your cache. Or maybe do it eagerly and also hold on to that and do it lazily, but also don't completely kill the daemon if you can't get to a cache basically. Also support multiple caches and take their priority into account. And allow racing caches with the same priority. So if you have nodes A and node B, well, try them both. Figure out who responds first, and if you can get a derivation back from one node first, then use that one. There's kind of a longer talk here about signatures. And this is kind of an issue with Nix in general. Basically, resigning derivations tends to obfuscate where they came from. So, for instance, NixServe, if you pass it a signing key, replaces the original signature. And this is an issue. Basically, it obfuscates where that derivation came from. You have to trust your intermediary node if you're using NixServe rather than the originating node. So you can't trust Hydra. You have to trust whoever's serving that derivation. And also, the kind of corollary to this is if you add more signatures that look like previous ones, it basically hides the purpose of that signature. So is this a build related signature or a caching related signature or what? And yeah, also finally, stop calling the private key a secret key. It's a private key. A secret key means something different cryptographically. Private key is the correct term. Secret key is what you'd use if you were doing like an HMAC or an AES cipher or something. And yeah, so in terms of other related work, M. Schwag did a talk called Rebuilding Builders Instead of Trusting Trust at NixCon this year. I would highly recommend watching it. Long-term better signature formats would be really good because you could enable policies for trusting distributed caches, which, I mean, if we want to distribute caches more, if we want to cut down the cost of the binary cache, which, I mean, I think a lot of the NixOS Foundation's money goes towards, sort of distributed caching would really help somehow. So let's go into some pictures. So here's what one of the nodes looked like at DEF CON. It's just sitting on a chair. Basically, we crammed all this hardware and all those antennas into these little backpacks. Here's what it looks laid out. So there's the node. There are two antennas on top. One's for Wi-Fi monitor, one's a Wi-Fi client. And then the mesh antennas are on the top of the central box, and the 4G antennas are on the bottom. And the antenna on the side is a GPS antenna, actually, because we were able to get the GPS from our modems working. And the battery's on the bottom. And of course, you can plug a bunch of Ethernet or Cat5e or Cat6 cables into it and get on the network. Here's another photo of one laid out, and yeah, you can see there are antennas everywhere. I think I counted like 9 antennas on these things. I mean, I think one of the things is it would have helped is if we had used RF cables for the backpack. All right, so now the next question is, did it work? Well, we actually had an internet connection at DEF CON 32, so yes. Well, the internet worked. These actually worked pretty well. We couldn't use the binary caches as much as we could have because the internet connection actually worked. It was more about the journey than destination, really. One of the actually coolest things that we were able to do is remotely deploy each other's mesh nodes while we were just carrying them around on the convention floor via deploy RS. So we were able to remotely, we had these backpacks, and we could just remotely deploy them if we wanted to make a change. And also, yeah, yesterday, many people got internet access over this at SCaLE. Actually, this thing doesn't have 4G service in here at all, in this room currently, so I was having trouble. And yeah, here's this PCB. PSA, if you're not silly, it's vital you become silly. Here's another photo of this. This was at the North County Nix meetup when the weather was, any good and cooperating. We were outside for one of these events, so we just had this serving Wi-Fi for us. So here's kind of the long and short of things, introducing NixOS. So this is an actual software release. It's a NixOS config flake for creating layer 2 and 3 meshes and using the host in them for binary substitution. It's very experimental right now. It's based on a feature branch of master, but it actually has end-to-end tests. So we actually now in Nix packages support testing of Wi-Fi meshes. The Kismet module, which is a Wi-Fi monitoring module, has tests to make sure that it can monitor traffic on Wi-Fi devices between multiple nodes. And we now actually include basically virtual Wi-Fi support for NixOS tests. Reviews are welcome, of course. The PR is up there, 380-819. And yeah, so if you'd like to play with a mesh node, just come find me afterwards. Some shout outs. I'd like to give a shout out to Andrew, Chris, Tim, the DC858, so that's the San Diego DEF CON group, and the SoCal Nix users group. And yeah, that's the code's all up on GitHub. It's very experimental at this point, but it's roughly what that's running. I think I need to redeploy it. Quick demo that will take less than a minute. So this is running the tests, basically. It will spin up a Wi-Fi network automatically, and they will just start pinging each other in the NixOS test suite once the derivation evals. It'll actually spin up, I believe, 6 different test VMs for this. Air Gap, Alice, Bob, Charlie, and actually 5 of them, and Dan. There's that hierarchical RCU implementation message again. Yeah, I'll just go through, provision all of the keys for all of the VPN nodes, which it's doing now for all of them at once. Good grief, the internet is slow. There we go. All right, now they're starting to ping each other. That one actually tends to time out for a second while the echolocation resolves the other node. But then it eventually stops timing out because they discover each other. There we go. So this is testing the layer 2. So this is the actual virtual Wi-Fi, basically. And it's about to go to layer 3. Yeah. Now here's Nebula going. So it's actually tunneling virtual Nebula, or rather, Nebula negotiating with a virtual TPM over virtual Wi-Fi networks over NixOS VM tests. So it's kind of like 3 levels of virtualization, actually. First test that they can ping all each other. That was Nebula actually rerouting traffic through a path that it found that was slightly better, that was faster, which is probably the VM management network. This is where it's testing all the binary caches to make sure that they're all up. And now here's where it's going to test the binary substitution, actually, from so all those messages were all of those nodes basically recursively substituting from each other based on, basically it was kind of a relay race of, one had a copy of that derivation, and the very last mesh node wanted a copy of that derivation, so they all had to substitute from each other, and then the test passed. So, any questions? That would be really cool. So, I mean, this test has 6 nodes, or rather, 5 nodes. Physically, we had 3 of them. Yeah. One of the, I only have 1 here because the rest are with buddies in Houston. So, yeah. And no, not yet. Although something like Scion would be really cool over this. One more question? But besides, so I believe when we talked about how we wanted to do this, which was, at DEF CON, we were like, well, we wanted to substitute from each other when we're in the same room. The short answer is no, because it was, the use case was, well, if we're near each other, like on a conference table or something, then we could do it. Now, more different physical layers would be pretty cool. Bluetooth might be a possibility for that, especially given, the ranges of it. But yeah, we focused on 802.11s. I think that's all the time for questions we have. Yeah, thank you guys. Yeah, you guys can find me afterwards if you want to play with us.
All right. All right, the next talk is from Mike Kelly, and it's building a Chromebook replacement with NixOS.
All right. Can you hear me? All right. Good morning, everyone. How's it going? Okay. Who here has given a Linux machine to friends or family? Show of hands. All right. Who here has regretted that decision? Yeah. Okay. All right. So yeah, this talk is basically my journey in trying to fix this problem. And so if you're new to NixOS and you're just kind of here, checking it out, this might be a good talk for you as well. This is not going to be super technical. This is going to be a little more desktop focused, which should be fun. So, and the project that I've built off of this is at github.com, mkellyxp/nixbook, and you can find me on Mastodon as well. That's on the last slide as well. So I want to tell you the story first of how I even got here, and it starts with a laptop, of course. So it was like 2020, pandemic was just kicking off. We all were bored and had stuff to do. And my parents gave me this old Lenovo tablet, computer. I think it was a Yoga 2. And it was broken, it had a bad hard drive in it. So I replaced it, fixed it up. And I was like, what do I do with this now? I wasn't a full-time Linux user at the time. I was hardcore in the Mac OS. And so, of course, I installed Linux on it. I was like, oh, yeah, let me check this out. I don't want to put Windows back on this. But that's a little bit of a lie because I put a lot of Linuxes on there. In fact, at one point, I think my wife came into my office in the middle of the night. I'm flashing USB drives like crazy. And she's like, what are you doing? And I was like, honey, I'm a distro hopper. So, yeah, it was bad. But the cool thing is that I ended up landing on Linux Mint, right, because it was just kind of easy and everything worked. And that experience was so good for me about being on Linux full-time that I ended up buying a System 76 Lemur Pro and ditched Apple. And I started my de-Appleification. So this is about 5 years ago, and I'm still full-time Linux today. So it was a success. I saw the light. I was a Linux user, much to the annoyance of all my friends and family. But that's not why I tell you the story of this laptop, right? This laptop also started something else. I no longer needed it, right, because I had my System 76 Lemur Pro. What do I do with this? I don't need the money from it, right? So I put Linux Mint on it, kind of set it all up, and then I threw it on to a Facebook free group. And I got hundreds of replies of people that wanted, obviously, a free computer. Who doesn't want it? But the cool thing about that is it started something. So in those hundreds of replies that I got for the people that wanted this laptop, I got a number of people saying, hey, I got an old laptop laying around, don't know what to do with it, would you like it? So you can go ahead and do this. And it started this cycle, and it's really cool. So from 2020 to present, I've given at least 400 or 500 of computers away in my hometown of Olympia, Washington. I'd love to see like a heat map of Linux users, and there's just going to be this red hot spot in Olympia, Washington. And we're like, what's going on there? So it's really cool. So meanwhile, as I'm doing this, as I'm like Johnny Appleseed of Linux computers out here, something happens to me. I start listening to Linux Unplugged. Well, actually, I was listening to Linux Unplugged the whole time. But then, I saw the light of NixOS. And I'll be honest, I bounced off it a couple times, and it wasn't really working for me. And then it clicked. And anyone who loves NixOS remembers that moment when it clicked. And I was like, oh, this is so cool. And, of course, I'm putting it everywhere, and I got NixOS everywhere. I loved it so much, I ended up writing a Medium article called Why Do People Love NixOS So Much, which then spurred into a Linux Fest Northwest talk I gave last year called 5 Reasons to Love NixOS. And that's my cat, whose name is Nix. So, the problem went pretty deep here. There was a problem, though, because here I am giving Linux Mint to people, right? But I'm using NixOS, and I love NixOS. But I can't give NixOS to some normal person. What am I supposed to do? In 6 months, tell them, listen, I need you to go into the terminal, switch your channel, do a rebuild update. There's just no way that's happening, right? And so I was kind of split in these worlds of like, okay, well, I give Linux Mint to normal people, and I use NixOS for myself. And over the years, I started noticing there are some problems with Linux Mint in the hands of normies, right? The first one is that like people don't do updates, like ever. Like you know this if you've given computers to your friends and family, you get it back and you're like, dude, do the updates. It just says you just push the button, but people don't do it. There's also a lot of times some scary stuff that kind of comes up. They're like, oh, are you sure you want to do this? And that's not even talking about version upgrades. Like, oh, you want to go to the next version of Linux Mint. Well, now you need to step through this wizard that's going to scare the crap out of you. Like, no normal person's going to do that. There's also kind of package repo confusion. So when normal users go into the software store and like search for Steam, they're like, oh, do I do the one with the LM on it or the one with the Flatpak logo on it? Like, there's that confusion there, right? And I get it. And then Linux Mint, they killed me with this one. They rolled out this whole unverified Flatpak thing, and I understand why they did it. But now there's a whole swath of the FlatHub software store that has this kind of scary, don't trust this badge on it, which again, we understand, but my mom doesn't, right? So these were the issues, right? So I'm looking at this, and I'm like, okay, Chromebooks are like ubiquitous. You just give somebody a Chromebook, and they carry on with their day. And I kind of have a soft spot for Chromebooks myself because they're just so simple. I love simplicity, right? So like, okay, what do I love about Chromebooks, right? So like, I love the automatic updates. It doesn't ask you, oh, are you sure you want to do an update? It just does it. There's no like kind of package repo confusion. It's easy. You just go into the Google store and click on the things that you want. The upgrades scary? Oh yeah. Oh, I don't know how I got back there. Sorry about that. Yeah, automatic updates, right? There's a nice simple UI. It's easy to understand for people. There's not all kinds of bells and whistles everywhere. Easier software choices. Again, just go into the Play Store and there they go. And I love the power wash feature. It's funny, when people give me their old laptops, they almost never know how to reset Windows, like to kind of clear it off to give it to me. I know it's not hard, but again, for more normal people it is. However, almost every Chromebook somebody's given me, it's been power washed because people just understand, like, oh, I power wash it and then I can give it to someone else. So I like that. So what I wanted to do was this. I wanted to say, okay, Linux Mint has been working for people for the most part. However, there are these catches, right? How can I combine Linux Mint, the lessons from Chrome, and build it in Nix? Could this be possible? So these were the goals of NixBook. So that's the project that I started venturing down. Was called, I call it NixBook. I wanted automatic background updates, right? I don't want people to have to worry about updates at all. Like even version upgrades. I don't want anything like that. It can self-update its own config, and I'll get into what that means there. But basically, like as things change, which they do, I want to be able to remotely fix that for people, right? A nice base immutable desktop, right? I want to have a nice simple desktop that they can't break. They can't like uninstall something and break it. It's nice simple UI, FlatHub integration, and again, just FlatHub integration, right? Like just simplify it to there. And then of course I wanted that power wash feature as well. So I was going to do, when I thought this was a longer talk, I was going to kind of do a demo, like let's build one. But I'm going to kind of step through this real quick, and you can follow along with this as well. And again, this is the end result of this all is at my GitHub right there. So go by this stuff, but I want to show you how easy it was to kind of get started down this path, right? So you can install NixOS and just choose no desktop, right? Go hardcore. And then you can go ahead and when it reboots, you just go ahead, do nmtui, grab your Wi-Fi. Once you're connected, you could use Nano or you could pull in a real editor with NixShell. Shout out to Helix. I love Helix. Yeah, all right, Helix fans. And then you go ahead and just edit your Nix config. Again, I'm not going to go too much into this. And then you kind of pick a desktop. So for me, I'm trying to rebuild Linux Mint, basically. And so I went ahead and used Cinnamon, right? So rather easy. You can see this is all the code to go ahead and get Cinnamon installed there. And then you go ahead and it's okay, what images, what stuff do you want in that base immutable image? And again, this is what I love about Nix, right, is that you get to choose what's in that base immutable image. People might download Discord or Steam or whatever they want, right? But they start with this. And so, just through trial and error, I got Git, Firefox, GNOME software, calculator, just a handful of stuff, right? And then the portal stuff for the FlatHub integration. And then, of course, there's like services, Flatpak, true. Real easy. So then let's configure auto updates real quick. This is super easy in Nix. What's great is like nothing in this talk, I don't do anything with like Home Manager, I don't do anything with Flakes. This is all just kind of bare, raw Nix, which is cool. So Nix has an auto update feature. And so you can see right here, in NixBook, I have it just doing it on boot, which means that it's not going to do a rebuild switch. It's going to wait for reboot to go ahead and do that. And again, stability is what I want here. I don't want to like hot swap somebody's kernel or desktop environment in the middle of them using it. That would not be good. And then garbage collection, right? Because everyone knows the Nix store can get rather big. So setting up automatic garbage collection too, 30 days is fine for most people, right? It's like if something hits the fan, they can roll back. And now, what about Flatpak updates, right? How do we do those, right? Because that will rebuild. This will rebuild every week. And then when the user reboots, they'll just have the new stuff. But again, remember, there's not that much stuff in that base image, which is on purpose. So what about Flatpaks, right? All the stuff that they installed via Flatpak. Well, you can write a systemd service, like a one-shot systemd service here. And so you see here, we're just setting up a systemd service. This goes right into your Nix config. And we can go ahead and we can just do a Flatpak update, non-interactive, assume eyes. And that just goes ahead and, updates your Flatpaks in the background. And I have that running daily because, why not? Most of the time it's not going to do anything. But again, it's great. And this all happens in the background. So I use this for my kids. All my kids run NixOS because, I won. And so they use it for class and everything. And you know how Zoom is like notorious for like, they go to hop on a Zoom thing. Your Zoom client's out of date. And you're like, oh, damn it. So it's so nice, because as soon as you open up the laptop, like that job will probably run in the background. And by the time you get over to click on the Zoom link, it's updated. So I just never need to worry about it anymore. So it's super, super cool. Yeah, and so once you do those things, that wasn't a lot of stuff, right? You can go ahead and do a NixOS rebuild, reboot it, go ahead and add the FlatHub repo, and that's it, right? You got yourself an automatic updating, kind of simple, basic software thing. And so you can run software, you can go ahead, you can grab whatever you want, you can change your settings, all that kind of stuff. You're done, right? And you can go ahead and you can look, and this is kind of cool too. If you want to confirm that everything worked, you can do systemctl list timers, and you can see, there's the NixOS upgrade, there's the garbage collection, and then there's the auto update config as well. So that timer's running too. So it's kind of cool. So you can check on it, make sure it's working. So somebody is probably thinking, wait a minute, Mike, hold up. What happens when 25.05 comes out? Because you went and hard-coded this channel here. Yes, I know. So obviously, if it's like for your kid or whatever, or like you have access to that, you can go ahead and just manually change it every 6 months if you want to. I did a different approach. So I wanted to go ahead and have that in a Git repo, and then have the Git update as part of it. So I'll show you what I did. So basically, all this kind of custom Nix stuff, everything that wasn't in the base, no desktop image, I sectioned off into a Git repo. And that's what you'll see on my GitHub as well. And basically, that's all this does. Like converting from a Nix to a NixBook is just basically this. Just importing this base.nix file right under your hardware config. And you'll see what I did is I added in my auto update config just a git reset clean pull. So that means that every day when it's updating Flatpaks, it's also going to update its own config, which is awesome. So now I have hundreds of these NixBooks out there in the wild. And when 25.05 comes out, I'll test it locally, make sure everything's fine, roll it out kind of slowly in my own house, and then I can just push it up to main, and everybody will get it within the day. And so that's pretty cool. So more channel problems. So I did that, and I was like, this is great. But then I realized, or somebody in the community realized, well, the problem is that if you manually run a NixOS rebuild, your channel is still technically the old one. And so there's some code that we added in there to do that as well. So it basically goes ahead and looks at what you have your auto update to, and will switch your Nix channel to it. Because in NixBook, you can automatically update it, or you can manually push an update and reboot as well. So yeah, so in NixBook, in this project that I did, putting it all together, I went ahead and wrote an install script, because who doesn't love a shell script? And yeah, I mean, as you can see, it's real basically. This is the whole thing. And this is what I love about Nix, is that Nix to me is like Linux Legos, right? Like this is basically a distro. I just made a distro, basically. And you can do that in NixOS so easily. So you can go ahead, you can like clone, you can use it as is if you want, keeping this up to date. You can also fork it and do your own thing, or just get some ideas from it. But as you can see, it's real easy. And really, all the magic happens is here. So all this does is like literally adds, it cuts off there, but it just adds that that base.nix file into your config, and then when it rebuilds, you're good to go. And then I didn't have it in here, time permitting, but I also have a power wash feature as well, which basically does this. It's basically this install script where it just blows away your home directory, resets everything up, and off you go. So this has been just fantastic, and it's been a game changer. And this is the outcome of it, right? So, I mean, that's so clean. Like, anyone can use that. That looks so much better than Windows, I think. And so this has been, I've gotten just such great feedback from regular people, like parents, people that have no idea what Linux is nor care. They're using this just fine, and it's great. And so by default, I go ahead and I add in Chrome, LibreOffice, and Zoom. Like, those are the three things that most people I find want. Obviously, Firefox is in there too, but I'm trying not to scare folks. So yeah, that's basically it. So again, you can find me on Mastodon. Yeah, cool. Trying to keep this a little tight. And there's the project NixBook. So, and I have time for questions. All right. Yeah, so good question. So the question was, is it okay to not use FlatHub? Can you just include those applications in the actual, build of your image? Absolutely. My goal with NixBook was to make something kind of general purpose, because I don't know what people are going to want to have, right? I don't want to assume everyone wants Steam or whatever. So like for me, it was like, okay, what are the basic things that we want to have, and then FlatHub for the rest of it, because that just seems to be good to go. What's that? Oh, yeah, FlatHub is fantastic. The question was, does FlatHub run well on NixOS? Yeah, absolutely. In fact, if you just Google NixOS FlatHub, you'll see like the 2 commands that you need to run to get it up and running. And yeah, it's fantastic. And again, the other thing is that people don't reboot their computers. I didn't get to talk about it, but one of the things in NixBook that I have is a systemd timer that runs and checks if the computer's not been rebooted within like 28 days or something, and it'll send a notification like, yo dog, maybe reboot. Because again, those rebuilds only apply when the computer reboots. So that's the other danger of, like, let's say you had Zoom in there in the base image. Well, they're not going to get that new Zoom until they reboot, after that rebuild happens, where the Flatpaks update every day, and they're separate from the base image. So, cool. Yeah. Yeah, so the question was, is this just x86? Have I done it on ARM? I haven't, and I have an Asahi Linux, an M1 Air at home. I should run on, test that out. But yeah, so far it's just been x86. And I have gone ahead and jailbroke a number of Chromebooks as well, and done this too, which is why, it kind of felt like a Chrome OS replacement. for it. But again, in theory, there's no reason why it shouldn't work. There's nothing x86 specific in there. Last time I was playing with Asahi Linux, my only problem that I had was like there's a number of things that just aren't ARM64 ready yet, sadly. Maybe next year we'll get there. But yeah, I mean, it 100% could work. Written back? They should. So the question was, do you know any schools that are using this for students' computers? Yeah, I mean, why not? Like, I think that would be really, really cool. What I'm doing in my town of Olympia, Washington, is it's a bit of a unofficial nonprofit, but I've actually gotten in touch with the school board to get their old Chromebooks, and there's a number of businesses around that, like, every year they just kind of buy new hardware and churn their old ones out, and so I get boxes of like Chromebooks and like Dell Latitudes and stuff like that, and they all get NixBook and they get donated back out to the community. So again, it's still kind of, loose there, but yeah, 100%. If I was on a school IT board, I would 100% do something like this. And you could pull FlatHub from it as well if you don't want kids installing their own flat packs, right? Over there.
Have you given any consideration to the user interface or user experience for when someone needs to revert or to go into and build a previous?
Yeah, generation. Yeah, so the question was, is there any, I guess, plans or user interface for if somebody wants to roll back, and I say roll back in air quotes because it's a NixOS generation, which is a little different. I mean, my goal is that normal people aren't going to have to deal with this at all. If maybe there can be some instruction around like, hey, if you reboot and things aren't right, reboot again and then choose the next option down because you'll have at least 4 generations, ready for you there. But yeah, there's nothing right now in like the UI that kind of lets you do that. Now I do have the power wash and the update and reboot. That's in the GUI menu. So I put those as like menu items. So like if somebody just wants to force a update and reboot, they can. Or if they want to power wash it, to go ahead and give it to someone else, they can do that as well. Good question. So the question was Chrome, Zoom, and LibreOffice, are they coming from Nix packages or Flatpak? I have them coming in through Flatpak. That was a decision I kind of had to make. For me, the cadence of Flatpak updates are faster. And again, I'm basing this off years of experience dealing with normal people that don't do updates. And so it's like, okay, I want Flatpak to do the heavy lifting on the application side. But you could totally. In fact, there's a variant of this called NixBook Lite that you can install as well. So you go through the whole process and instead of install.sh, it's install-lite.sh. And what that does is gives you that same basic, UI, Cinnamon UI, but it just has Firefox, and it doesn't have any FlatHub integration. So it's essentially like a netbook. And that's if you're really resource limited or want to lock it down. Right up here.
Are people using Flatpak a lot, and do you like to install their own apps? And do you have a forum or anything where people are giving you feedback about things to improve or if they're in trouble?
Yeah, so the question was, are people using Flatpaks and going ahead and doing that? And then is there any kind of like forum, like feedback? Yeah, I mean, I'm following up with people that I donate to. I'm pretty active in my local community, and I do follow up with people, mainly because I'm just morbidly curious that normal folks can use Linux. Like, it always makes me just happy. Yeah, absolutely. And again, there actually has been a couple on Mastodon. I know there's a guy, Phil, I forget his username, but he put some PRs in there too, where you'll see in the final code of NixBook, even those Flatpak updates, we actually deprioritize CPU. CPU and disk priority. So it's not as resource intensive if you're hitting that. You don't want to open your laptop and it's suddenly slow. So yeah, there's all kinds of great feedback. And again, obviously, this is kind of a world torn, right? So like, there's the people installing this for people, and they're the ones that are going to go to GitHub and open a PR or an issue or something like that. And then there's like regular folks like my parents and kids and people in my community. So there's no formal feedback loop right now. I would love that though. That would be That would be awesome. And part of the reason I want to give this talk here today, too, is to kind of, get this, get more eyeballs on this, right? Because I would love for this to be a bigger thing. All right, one more.
On his idea, maybe you could include something like, I don't know, Slack or something that's already there as like a help desk, so that there would be a feedback mechanism like on the laptop.
Yeah.
And then, oh hey, this isn't working for me. You could at least get some feedback from users.
That's a good idea, yeah. And you'll actually see in here, as part of the repo too, I have a getting started PDF, which isn't, I know a PDF is not the same as an interactive, help thing. I mean, this also isn't my job. And so I don't actually want to be people blowing up my phone or anything too. But I do like that. There is a lot of room for improvement for, better feedback with people. But again, in that getting started guide, I do have my GitHub and my email. And again, I'm just getting kind of informal, feedback from this. But yeah, it would be fantastic to go ahead and get something more official. So, all right. Well, thank you guys so much. And
All right. Can everybody hear me? Cool, cool, cool. Thank you. All right. We're going to get started. Sorry for running late. Sounds good. Hey, everybody. Awesome second day. I haven't introduced myself enough. I'm Ron, one of the co-founders of Flox and president of the NixOS Foundation. So excited to be here again, excited to be part of organizing this. And we're going to do a little Nix State of the Union. We love to do this because Nix has so much happening that it's good to kind of remind ourselves what's been going on, take a quick pause, and take a look at things. So I'll get started. Again, we've been thanking them a lot, but we can never thank them enough. So thank you to everybody that made this happen. Now, how many of you have ever heard my reference about veggie goulash? Yes, less than 10. All right, so I get to say it again. So one of the things that I've been in conflict with for about like the last 5 years, 6 years now, since I've been going deep into Nix, is like, how do I explain what I do to my mom? Okay, I don't know if anyone of here has ever had that reference. Your mothers, your spouses, your partners, your high school teacher, whatever it is. And I've landed on a reference that seemed to somewhat stick, but I'm not yet fully sure of it. We'll see. So the way I like to think about Nix to folks that are non-Nix initiated or maybe not super technical is like veggie goulash. So I have very mixed background in my heritage. So I had a great-grandmother from Poland, and she would make this amazing veggie goulash. She sadly passed away a long time ago, but the recipe lived on. But everybody has these kinds of recipes that they kind of pass from person to person in the family. It's ink on paper. It tells you what ingredients you need. It tells you how to put it in. Maybe it tells you Fahrenheit or Celsius, and you do the conversion yourself. And at the end of the day, it never comes off. That's the same thing because recipes are not reproducible. Here's the big but, and how I like to think about Nix. I like to say, hey, Mom, imagine you had a magic cookbook. Imagine that magic cookbook was written by our great-grandmother. And again, it had all those recipes. But when she wrote down 2 tomatoes, 1 zucchini, little paprika or whatever it is, that magic cookbook actually materialized that exact tomato that was grown in the exact soil with the exact acidity that she had in her backyard or at the farmer's market. And that showed up in your kitchen when you were starting to cook that veggie goulash. So that's Nix to me, right? Because what if we can make that veggie goulash taste exactly like Grandma made it? And that's what we can do today with software. So I still don't think anyone understands what I do that is non-technical, but it's an attempt. Now, I've been coming up and talking about Nix at a State of the Union-esque thing since we came back from COVID. I think that was 2022. It's now three years going now. No, it might have been even 2021. We've always been talking about how amazing the growth has been. I mean, just turn around, look at this room, right? We're now in North America, we're not in Europe. And this is the crowd that we have around us, which is pretty incredible. So we've been a lot of the time talking about growing and growing and growing. And what I realized last year where it's like, it's not about growth. It's about how can we make sure that all of us, and probably many more across the world, are here 10 years from now, right? How can we make sure Nix is here 10 years from now? And what do we need to do that? So I started thinking a lot more about, growing Nix and a stronger Nix to more of a, how do we build a sustainable Nix together that can be here for you, for me, for the folks that haven't even heard about Nix yet, 2 years from now, 5 years from now, hopefully 50 years from now, and there'll be like a picture of this room like in an old hotel and some like really bad graphics. Be like, hey, these were the old people. So when I think about sustainable Nix, it's split into this triangle. I come from a world of saying everything in threes. If you ask anybody in the company that works with me, it's always a 3. Even if I have a 2, I'll make one up. This one I didn't make up. So threes. For me, making a sustainable Nix is about doing 3 things. It's about how do we ensure that everyone here, everyone online, everyone contributing to Nix, there's a motion of sustainable contribution. How do we ensure that there's no burnout? How do we ensure that the folks that have all the experience are able to bring that forward? How do we build up new contributors and how do we welcome them, right? There's always kind of a friction. There's an imbalance that happens, but how do we make sure that's something that we can do in 2027 and in 2030? That's a big piece of what we've been thinking about on the governance side and in general in Nix sustainability. The second piece of that is resources. That's pretty blunt, That's pretty blunt, right? We have money in the bank. We'll show you. The minute I got in, one of the things I wanted to make sure is that we have super transparent policies around everything. You know how much money we have, you know where we put that money, you know who we got it from. Because otherwise, I don't think that a community can work together at a wide scale. So sustainable resources is pretty direct. It's how can we start thinking about not do we have enough money to give infra for the latest thing, it's how can we make sure that we reduce reliance on variables outside of our ecosystem that we have less and less control of, right? And for me, that starts coming into how can we create repeatable formats for our profit and loss where I can say with a high certainty that in 2027, we're gonna have this budget. Right? So when infrastructure comes in and needs something for migrating off Hetzner or needs something for an S3 cache, we can say 2026 and 2027 is covered, right? We have something to actually back into. That's what I'm talking about in the sustainable resources front. I think there's a lot of work there because there's also a lot of governance and community work in terms of how do we interact with folks who can fund us and approve funding and commit to funding that is multi-year. Because we can only go so far on donations that can come in one day and totally be erased the next, right? And we've seen that. We've seen folks who have been amazing donators, you know, at kind or whatever format for 13 years, but then they get bought, they get switched, and suddenly we need to go and figure out something to do. I want to be able to make sure that every year I can stand up here and say, well, not me, hopefully other people can stand up here and say, hey, this is the 3-year plan. This is the runway we have, and this is where we're investing into. And the last bit, this has been going on, and we're going to be talking about that over the next 15 minutes a lot, sustainable governance, right? I think it's a pure evolution of open source. We start with Mr. Ilko sitting over there, and he brings this genius solution out into the world, and a lot of us are rallying around it because we want to work on it, we want to contribute to it, we want to be part of it, and we want to bring it to the workplace, to our hobbies, wherever we want to do it. But there's a sustainable evolution that happens between that to where we need to go as we've grown. And I think we've seen that in the last 12 months, right? Not to get too deep into it, but things like having an SC, having a foundation, how do they work together, having formal teams is big here. So apologies for the graphics, they look horrible, but just a quick, what happened in the last year, right? So we formed the Constitutional Assembly. We then went in and we started forming the Constitutional Assembly, helped us create a new governance format. We had the first ever election inside of Nix since it was born almost exactly 22 years ago. So in just like, I think, Ilko's 6 days, we're celebrating this. Maybe 6? Okay. Concerning look, maybe 6 days. We formed the first steering committee, right? And now, just in the last few weeks, we had the first NixOS Foundation rotation. So things are moving. I think this is how we're structuring sustainability. With that said, I do want to have Sylvan join us on stage. The whole point of the State of the Union, sorry, copying time, yeah. Yeah, this one. The whole point of the State of the Union is to bring amazing folks that are just out here live with us to talk about the things that they're doing. So thank you so much.
Yeah, hello, that's smart.
See?
Test. That works. All right. Yes, I'm Infinisil Sylvan from Tweak, and I've been very involved in restructuring the governance in the last year. And so I just want to present the steering committee. I'm not on the steering committee, but I was part of the lead in the elections for the steering committee. We had 450 contributors vote for these 7 people. Well, and way more. We had over 20 nominations, and these 7 had the most votes. And so I want to welcome John Erickson, who sits in front here, to the stage, and Tom Barek. Oh, Tom is also here. Yeah, so these are the 2 steering committee members right here. So Ericsson, John Ericsson, Ericsson 2314. We have Tamberek, yes, and then we have Gabriella, Franz, Robert, Winter, and Jan, who are not here right now. Yeah, but these exist now, the steering committee, and I guess I'll get to that later, but they can be contacted. There's email, there's GitHub, and on Discord you can also send PMs. So yeah, I'll skip ahead, and you can stay here for a bit. I'll get up. So the next step there was, once we had the steering committee, so rewinding a little bit, before we had the election, we in the assembly, and that's another group of people, but we wrote a constitution for how to have the elections, how this influences the board, how that all works together. You can look at that. It's in a repo. But yeah, so as part of this constitution, it's also that the steering committee approves the foundation. So we have some kind of checks and balances in there. And so we have a new board. Since a couple days ago, it has been approved. And so I want to welcome Laszlos and Sebastian, and yeah, and Ron is also on the board, and me, yes. And we also have Ryan Trinkle, who I think should be here, but we haven't seen him, so hopefully everything's good there. But yeah, these, kind of mixed bag of steering committee and board members here. So yeah, what does each body do? So here's a link, here's where you can find the constitution. It's in the newish org repo, docconstitution.md. So the steering committee is more on the kind of community side of things. So that goes into the technical leadership as well, social leadership, sets the product direction. There's a whole bunch more, also acts as the kind of final escalation points in case of conflicts, and so on. Whereas the foundation board is more on the legal, administrative, financial side of it. Kind of, as Ron wrote it really nicely, keeping the lights on and helping the light shine brighter. Yeah, and also about relationship, external ones, partnerships, sponsorings, and so on. And of course, if there's matters relating to both, they work together. And yeah, that's kind of a very brief summary of the responsibilities which are laid out in this constitution. Yeah, this is my last slide. And this general org repo was kind of a recent effort in order to make the whole organization of official efforts more transparent, more explicit, more discoverable. So it's pure documentation, but it's very clearly laid out who owns which part, how to make changes to it. There's regular reviews to make sure things don't get out of date. It also newly defines what is actually official. We haven't had a definition for what is official up to recently. It's been just kind of up in the air or de facto what people think. You can, as it's a normal repo, you can request peers. You can request to get, for example, access to things as well. You can make issues and the right people will see it and can redirect you to where you can request changes and so on. Yeah, and that's being worked on. I work on that a lot, but yeah, that's.
Awesome. All right, thank you, Sylvan. We're gonna invite more people in a minute, so you guys don't have to stand on stage. I'm gonna do this real quick because I want to make sure that we stick on schedule. There's a few other people I really want to talk to you about areas inside of Nix that do need shout outs, do need to tell you a few things. But just a quick Nix in the numbers, because this is a tradition now. Nix is growing. I don't think anyone here is surprised. I mean, things are kind of like multiplying every freaking year. At the beginning, like I said, it was exciting. Now when I see this, I'm like, oh boy. Our cash. That's going to cost money. Again, AWS has been like an awesome sponsor, and every year I've been like, we need to like increase our budget by 50%. They've been like, cool. So it's nice that they're also expanding usage of this, so there's like mutual needs there. It's growing, right? So just like, it's growing. Look at that. Still being talked about. I think every 2 weeks, I wait for the traditional front page Hacker News post about Nix. I think it's now been like, the way I count it is if 3 out of 5 are not negative, that's a good week. And so far, we've been trending to like not negative. It's been like pretty good. So I love that. Obviously, cache is where we're spending a lot of our resources on, right? Hetzner, stuff like that. Folks are aware of it. And it's growing. So the one thing I want to add before, if folks don't know Peter Hitchens and are interested to be a more integral part of an open source system, please read this book. He has a few books. Social Architecture, Peter sadly passed away very early on in his life, but I think the way he thought about open source and what open source brings to the world was a very, that's the view that I take on. The biggest quote that I like to kind of live by as we're addressing these things is that it's community before code all the time, right? We can have a lot of code. If we don't have this community and that community globally to go and make that happen, nothing really matters around it. So this is also something that personally I call out very explicitly when I talk about things also at the company level. Without the community, there is nothing. Quick foundation, look back, lots happened in 2024. The main focus was sustainable governance, right? What we can do to create the NCA, support the SC, do the rotation, lots of stuff in between. And looking forward, we're going to be formally putting together that rotation. There's a bit of paperwork that needs to be signed, sent over to some Dutch folks, and all that fun. And then there's going to be some formal 2025 planning. We already have some things in mind, but at this point, I really don't want to speak as a solo person. There's a team. I want that team to come together and kind of talk to the community about that. Transparent financials. So we're good. We have the funding that we need. We're good for 2025. Just a little bit of a look at things. Most of our losses are indeed on the cache side. And then after that, there's obviously Hetzner and hosting and a bunch of other things, but I'm trying to really make this quick. If you're new to Nix, there's so many resources out there. Everything from discourse to the matrix, the community is super amazing. There's no such thing as a stupid question. There's also awesome initiatives run by individuals in this community called things like Nix Academy. So if you're looking for Jacek, he's right over there. He's just purely focused on helping you understand Nix better, which I think is really, really amazing. Nix teams, if you're interested to contribute and take part, there is a lot of different teams. And if we don't have the right team in place, suggest it, talk to the SC, mention it to the board, mention it to someone you think is part of the community. There's no blockers. I want to make that explicit. If you have an idea, let's talk about it. That's the whole point of open source. I'm going to welcome Tom back to the stage to talk a little bit about Summer of Nix and infrastructure really quick because we're tight on time and there's one or two more people I want on here.
Yeah, so Summer of Nix, this is a project or a program that started a few years ago. It started out with some funding from NLNet and NGI Zero, and it kind of is a big thing for the community. It brings in a lot of people, brings a lot of newcomers as well, and is a way to kind of get people started into the ecosystem. And you do a lot of packaging work. You do bunch of just stuff to make software more reliable, very much focused on privacy and self-hosting. So that's a pretty good effort. It's been going on every year. Kind of the style has been kind of changing here and there, but if you're interested in anything like this or want to help organize it or be a mentor or participate yourself, please let us know. Yeah, we're also trying to get a little bit more repeatability here because it seems like this is a good program. So we're also building a team to kind of help have the working on it be kind of a bit more consistent year to year. So let us know if you're interested. Infra team. We don't actually have a lot of some. I'll just kind of talk through it. Some of the big stuff they've done this year is upgrading the hardware for the build farms that we have, migrating away from Equinox that we lost that kind of sponsorship to Hetzner builders. They've been working on of Borg, some of the Nix packages infrastructure, make that more efficient. That's been good progress on there. And they're trying to kind of transition also to doing a self-hosted mail. But contact anyone here if you're interested in infrastructure. There's obviously always more and more work to do. So let us know. And also shout out to John Erickson for doing some more work on Hydra. Keep up the good work. All right, Infra team works on the build and cache. Has some details here, but there's all sorts of services that are for the community there. And yeah, so I guess we'll just go with that for interest of time. But if anyone's interested in any of this sort of stuff, please contact Infra Team and get involved because this whole thing is like very volunteer driven, and well, we need more volunteers. That's you.
Sweet. Lassless? We're doing hot swaps over here. Thank you
Okay.
guys for bearing with
So
us.
moderation, since the last NixCon, we added Alexander as new moderator, and Hexa and Endocrimes left us from the moderation team. They did a good job, so thanks for them. And since with this, the whole moderation team basically rotated since the last year. So I'm the oldest moderator now, and that's basically it. Next.
Sylvan. Sylvan.
Sylvan again. Okay, here's Sylvan.
Oh, that's me?
It seems so.
I didn't think so.
Oh. So if it's on you, you can skip it. Next one.
Sure. Yeah, formatting team. So I'm the non-governance related thing I've been doing is the formatting team. So it's a Haskell code base. Became official the last year, and we're currently working on it being used in Nix packages. 2 new members just last week, and Tom was also actually a previous member. But yeah, so currently big PRs. First one was merged. Second one is being worked on right now. Hopefully, being merged in the next couple of weeks. After this, you will be able to set up your code editor to automatically format with Nix FMT, and won't have to bother with formatting things ever again in Nix packages. So very excited for that.
Marketing team, Dan. And by the way, I want to call out that if you're seeing multiple people in multiple teams, that's a sustainability issue. So just keep that in mind.
Hi, my name is Daniel. I represent the marketing team. We had a bit of a lull last year where we were in maintenance mode for about 6 months or so. Since then, we've kind of reached out to each other and said, let's get motivated again. Let's get moving. Start being more active on updates and socials. And at the beginning of the year, we've started doing so. We've got weekly meetings now. Socials are more active. Website development's more active. We started also looking at branding. But we, again, are a very small team, and we could use help. So if you have any interest in working on our homepage, helping out with social media, branding, or marketing in general, if you have ideas about marketing, please swing by. We have a weekly meeting. We also have a matrix space. And yeah, help make this number keep going up.
Just to add a emphasis on marketing, like this is not just about, this could also be about how do we put words together to explain things to people. So if you have thoughts on that, I think that's one of like the hardest things we've been working on at Nix for the longest of times. I wouldn't like measure it against other harder things that we've been doing, but like explaining Nix, I know a lot of thought went into that. You guys do it every day, maybe every week. That's a big part of marketing. Sorry.
Absolutely. Do we have, okay. Oh, made pretty slides, thank you. So, results from the survey from last year, we had about 2,300 answers, full answers. So that's a 30% increase from the year before. So again, number keep going up. So that's great. And also I think, let's see, we had 27 questions, 39% new, and I think there was, oh yeah, this is a really big one. 40% of the respondents have been using Nix only within the past year. So that's outreach, that's growth. It'll be really interesting to see what that number turns into again for this year. 90% of the people responding use NixOS. It is core, it is central. People like using NixOS that use Nix. Also 50% of the people actually use it for software development or use Nix for software development. Interesting number. We're kind of thinking about like, what do the other 50% do? So we're refining questions. This is actually another responsibility of the marketing team is coming up with survey questions and then processing the data from the survey. And also, our biggest avenues that people are learning Nix is, well, first from YouTube, then through their friends or through word of mouth, and then from Reddit. Now with all these numbers, and there's plenty more numbers if you want to look at everything that we've processed on the discourse. If you look for the survey 2024 results, you should be able to find it pretty easily. One thing that we've noticed is that there's still kind of a bias within the numbers. We only have like a partial data from the community. And so this year we hope to do a little bit more outreach and promotion of the survey to get an even larger capture of what the community is like and what their answers are, and have a better kind of data to process. It's kind of hard to actually extract information when you only have a partial representation of the community. So next year, hopefully, or this year will hopefully be better.
Cool.
Next team.
John.
Hello. You see me already. I'm John from the Nix team. So yeah, first let's recap what we've been doing. We meet twice a week to triage and review, and doesn't say it, but also do development work. Please come to our meetings. They're supposed to be fully public. They're on the calendar. And additionally, you can find us in NixDev, NixOS.org on Matrix for all your rest of the week needs. We've done a number of releases. I think, yeah, 2.26 was the last one most recently, and 2.27 is about to come out. And we've done a few major projects around contributor experience. The Mason rewrite is finally all done. Some core things from me and a bunch of the second and third and fourth, 90% from Robert. Thank you, Robert. Modularization and layers. There's now, with the Mason stuff, more separation. And build times, again, leveraging the Mason stuff, and along with the layering, more separation, so that if you only change a CLI thing, let's say we're not going to rebuild the core libraries beneath it. Likewise, we've also been talking about how to finally bring our experimental features to a close, more on that later, and incrementally stabilize things so that that was shrinking. This year, I think the biggest thing we should do, and this is also just tentative, but we've started talking about it, is make a public roadmap. Every time I come to these conferences, I'm always sort of mortified on just how opaque we all are to most of you in terms of what's the plan, what the hell are we doing. So that needs to change. And along with that, increase the pace. So find more contributors and find more time and funding for ourselves in addition. You know, the roadmap and the plan and the resourcing, all that naturally works in synergy so we can really make big strides and make cool stuff. And again, a big part of that roadmap has to be shrinking the number of experimental features so there's more clarity about what's going on and, you know, where we're at. Lastly, contributor graph. Like all the other graphs, the line goes up. It says October 23, but no, it goes to 2024. Line still goes up. I think that's the next slides. Thank you so much.
Thanks, John. All right. So I want to be short here. There's a lot of things going on. There's a documentation team. There's a general effort between the SC and the board now that we're going to be kicking off in 2025. Not kicking off, but continuing to invest in regarding team empowerment. Obviously, there's release management happening. Tristan Ross is, by the way, somewhere here in the conference doing cool. Oh, there he is. Talk to him about it. There's a lot of things happening there as well. Speeding through this all doesn't matter. That's my dog. He's gotten really big. He's actually here. He wasn't allowed to go into the conference, so if anybody wants to see him, I'll bring him in the afternoon. The one thing I will say is we have a traditional end of conference photo. If you're down for getting your picture, after the event ends, after the last session stops, I'm going to shout somewhere in the open space. We're going to get up here. We're going to take a picture. It's going to be really beautiful, and we're going to be the best-looking open source community on Forbes at some point. Nix coins. So Ross gave us a little whirl this time around. We've been having Nix coins for a few years now. Now we have Nix Squircle. How do you call that? It's like a square with. Thank you. That we now have that. That's cool. Go check it out. Otherwise, really appreciate you all being here. Really appreciate this being this first Planet Nix. Thank you that everyone took part in speaking up here. Yes, Fareed. Yeah, so I think 100% that's a really good question that is pertaining a lot to the steering committee. And I don't know how much time I have, but I think that's something that I definitely want to talk about. So I'm looking at Zach, he's saying 0. In general, I just want to give my personal opinion. Like, we now have a new board, so hopefully now we can go kind of standardize some of these things. My personal opinion on, sorry, repeating the question, it's kind of like what's going on with all the forks, what's our stance on the forks, what's the steering committee foundation doing in all that regard. My general stance on forks is like, this is what it means to be open source. If you have a better way to do something and forking is the right option and you fork and you do it better, then eventually, like, why shouldn't we all learn and continue to grow together? That's like my general mindset. I do want all the folks working on Nix related things to think about it as one ecosystem and not more of a, hey, I'm going to go off here and do something really cool. I've been following a lot of TVIX. They've been doing some really cool things. Like, there's really cool people out there, really smart people building really smart things. So in general, I would love to see us have more coming together and making things better in general. But I do promise that if you do have questions, that's why steering committee here, board is here. I don't want to take up more time from Zach, and I'm happy to step outside and talk about that. So anybody that wants to talk about forks, I'm actually going to be outside to talk about forks. Again, thank you. Picture at the end. Thank you to everyone that joined me, and have a good rest of the day. Steering committee. We have a fork question. Let's go step outside and see if anybody wants to join here.
tweeted one of my tweets about the Filio, so that's awesome.
Yeah, I met him in person. I think we both.
Oh. This will take me like
All right, folks. Somehow this talk disappeared from the schedule between today and yesterday. So we have a quick talk from Tristan Ross about using remote builders in Nix. Take it away.
Yeah, so in many cases, you want to be able to use a remote builder, which is basically just using SSH and having a Nix derivation build through SSH. This is very useful for if you're not wanting to use cross-compiling and want to natively compile something on ARM or x86 on a different system or a different operating system. You can use a remote build. So, hold on, there it goes. So yeah, that's one of the reasons. Another one's like lack of resources. So let's say you have just a MacBook with like 8 gigs of RAM. That's not enough to do something like build a Linux kernel. So what you can do is just tell Nix, hey, build on this Linux server that's got like 2 terabytes of RAM, and it would build it. And so so the way you set it up is actually really simple, but the documentation does not make it simple. You have to use SSH keygen, which generates a key, and then you will just set it up like you are doing just the normal SSH setup. But then you have to copy it to root, to your root user, and from there you have to fingerprint as root to then have the IP address and all that, or the public key gets stored in the fingerprint. And so from there you can configure Nix optionally. There is a machine file that you can set up where it tells it the IP address or host name to use. You tell it the features, the architecture, and all that. Or there is the builder's flag, which works very similarly to the machine file. And so one of the things with this is there's a concept called features, which describes what exactly the system supports. So this is things like KVM, so whether or not the system has the ability to run virtual machines on the hardware. There is the NixOS test stuff, which is left over from previous Nix versions. There is this recurse Nix one where Nix itself does not allow itself to be called from within the sandbox. So recursive Nix allows you to use Nix inside of itself. CA derivations, which is content addressed derivations. That is entirely a different concept that would take too long to explain. UID range, which simply does stuff with a sandbox to allow containers. Some of the limitations with remote builders is SSH can disconnect if you have networking issues or just any sort of issue with the host or target system. Builders can still run out of memory. Doesn't prevent that, which makes sense. You just have to just tune the builds right using the cores or jobs, which limits how many Nix builds or builds within Nix to run. And then fingerprints have to be fingerprinted sometimes, especially with VPS services that may not store the fingerprint always. And so an easy resource to look at some of the stuff is just the Nix manual, even though it's not quite entirely clear that it does still provide information. And so I can actually possibly spin up a build here if the Wi-Fi is good enough. To actually show what the machine flag looks like. So can anyone see that well, or do I? Oh. All right. How's that? So this is what the builder's flag looks like, which is the same thing as how you would use the machine file. And what this describes is to use SSH to connect to a machine called Zeta 3A with the architecture or the platform of 64-bit ARM on Linux. Then it says that dash just means to use the default key for connecting. Then it says to do 8 cores and 8 jobs with a big parallel, which is just a leftover thing to make sure that large jobs can run, and then KVM for tests. And then J0. This is actually very important because if you have an architecture that is the same, or the platform that's the same as a host, then it will mix jobs between your host system and the system that you're trying to connect to. And then when you run it, it'll have to evaluate, but it will push a machine build. It does not eval on the target system. It does all the evaluations locally. So at least you can save memory on your target system if the evaluation is big. But as you can see, it's starting to pull from the cache, and then it's going to push to my system that does all the remote buildings. So any questions? So what it looks like on the target. So the configuration is pretty simple. Just enable SSH, I believe, and you have to enable trusted users, I believe, is another one. I think both. It's either the host machine that you're running the evaluation on, or the target machine have to have your user as trusted to allow it, especially with substitutions. So how to get that fancy progress, that's actually a program called Nix Output Manager, or Monitor, also known as NOM. It is a very handy tool to be able to see exactly what Nix is doing, and it's available in Nix packages. So you're trying to think of how to restate this question. So you're basically asking like how to use other protocols with Nix. As far as I can tell, there is 2 protocols only supported in Nix at this time, SSH and SSH-NG. Both do the same thing, but I believe one is using a different library. I'm not entirely sure. You would have to ask the Nix team, but being able to support another protocol, it's just the matter of making the changes to Nix itself and making sure that both the host and the target system can utilize that version of Nix with the specific protocol. So, uh, can you cross-compile with other architectures? Yes, it's generally the same as how you would with host. But the benefit with this is if you have a machine that is more capable than your host machine, then you are able to just natively compile for that architecture or operating system. In Nix packages, we have an easy way of being able to do cross called packages cross, and then there's various platforms in there like Arch64 multi-platform, GNU64, which is x86-64 Linux, and there's PowerPC, RISC-V, all that. You would have to look at the lib systems examples.nix file with Nix packages to look at that. But the problem with cross-compiling is that it initializes a special part of Nix packages is standard environment, or standard environment that changes the base derivations. So you will not get the same exact derivations as a true native compilation. So that means it's not entirely pure because you still have host intricities in there instead of being purely native. So about sci-fi, I was gonna do that, but I just didn't get access to that system. And I was gonna do an Ampere demonstration with it, but the Ampere is out there and the Wi-Fi's just been flaky this morning and cellular is just not working. But this is trying to do it on my Ampere at home, which may or may not work. But it does work when I try it at home.
Oh,
It is just right here.
Mhm.
Yeah, just move it to your mouth.
Yeah.
No,
Mhm.
he's just testing the setup.
Testing, testing, testing.
Yeah, so if you it's just flipped. So
It's upside down.
Yeah.
Um,
Exactly.
oh, there we go. Yep.
Exactly. There you go. Just make sure. Yep.
Yep. Awesome. So it's now on?
Yes.
Okay. Yeah.
You ready to go?
Yeah, pretty much. If you want to wait a minute for it to trickle.
Yeah. Yeah. Yeah, I was eating lunch, and then people started coming into the other room because I was in the workshop room. I was eating lunch, and people started trickling in. I was like, "Why? Oh, fuck."
No, I had to speed walk back from lunch also.
Yeah, yeah. It was worse last year because I only scheduled an hour, and I was like, "Oh, it's fine, right?" No, wrong. So I gave us an hour and a half, and
Nice.
yeah, yeah. All right, just let me know when you're comfortable with the trickle being done. Yeah, as long as it doesn't go over by like 10 minutes, like we can usually like wiggle room it around. Yeah, Ron's State of the Union thing definitely kind of fucked the schedule immediately after it, but
I see. Okay.
yeah,
Makes sense.
yeah. Hey Tom, do you want to make an announcement that we're starting talks? He's loud.
He is. I forgot.
Yeah. Jesus, I can hear him from here. So where are you based?
What was it?
Where are you based? Like
In San
when-
Francisco.
Oh, nice.
Yeah.
Um, I am in Boulder, Colorado.
Back to Colorado in a while.
Yeah. Do you like live there at some point, or
No, just
visited?
passing by.
Gotcha. Okay.
Whenever we're ready.
Yep. All right. All right, we're going to go ahead and start with our next talk after lunch. This is Victor Fuentes with Tvix Store in production.
All right, testing, everyone can hear me? Okay. Hello everyone, my name is Victor Fuentes and today I'm going to be presenting Tvix Store in production, how we use Tvix at Replit. All right, so first, who am I? My name is Victor Fuentes. I go by VLinkZ on GitHub and on social media. I've been a NixOS user since around 2021. Some work I've done, I ported the Calamaros graphical installer to NixOS. Some of you may have used it. I've also experimented with some other graphical tooling for NixOS, such as like Nix Software Center. It's like a graphical app store. And now I'm working as a platform engineer at Replit. Okay, so what is Replit? Replit's a web application development platform. We have this AI agent that lets you talk in natural language and it creates code for web apps. We also have pretty much a full IDE implemented in the website. And the important thing, how does Replit use Nix? Every user gets a full Linux container, and these containers use Nix for package management. Another cool thing, the AI agent I mentioned can install Nix packages and run them. Okay. So let's talk about what some of you may have heard about local overlay store used at Nix. So in order to have some faster dependency installation, usually when you install dependency, pull stuff from cache.nixos.org. Takes a little while. Since we're serving all these Docker containers, we don't want just so much ingestion into our system. So we have this persistent local Nix store disk. It has a snapshot of pretty much all open source packages from cache.nixos.org for every single NixOS release. So this giant disk gets mounted into our user's Docker container. And in order to still allow them to put their own custom Nix packages, use Nix how they want to, we also overlay a mutable Nix store using overlay.fs, so that's mounted on /nix/store. And then using the experimental local overlay store flag on Nix, this allows us, Nix, to know like where the metadata is for each of these stores. So the metadata for this read-only persistent disk reads it from there. The metadata for the mutable user files reads it from there. That's great. So this has been working great for us for a while, but as the years have gone by, this persistent disk has continued growing in size and growing in size and growing in size. It reached a maximum of around 20 terabytes. Some of that was not Nix stuff, but a lot of it was. So this was costing us a lot of money, and we needed to find some better solution to this. Another thing I want to note, incremental updates were not as feasible since we do deploy this disk in a number of different regions, and replicating that across the regions was extremely costly, especially when it was 18, 20 terabytes large. So we're looking for a solution that we wanted to keep all the cached Nix store paths in that cache, because users are already linking to them, symlinks, dynamic linking, but also reduce the size of this disk. So the solution we found was using Tvix. So what is Tvix? Tvix is a modular reimplementation of Nix written in Rust. It has a number of different components, and they can be used in different cases, very modular, and the one that we're going to be looking at is the Tvix store. Okay, so what is the Tvix store? Tvix store, let's talk about Tvix CA store first. So Tvix CA store is a content address storage medium. So all the files, directories, blobs, stuff gets stored in a chunk content address format. I'm going to talk about more in a second, but pretty much the Tvix CA store doesn't know anything about Nix. That's just how we store the files inside of it. The Tvix store wraps around this Tvix CA store, and you see this blue path info. That is a linking of, we have this Nix store path. Here's like the hash. How do we go from there into this Tvix CA store land of content address stuff, and how do we get the data from that? Each of these blue nodes can have a number of different backends. So for the blobs, we can have local blob storage on the disk, but we also have features where it can access cloud storage like S3 or GCS. The directory and path info can also be a local REDB database, but it can also be like a cloud big table. Okay, so let's talk about, so this Tvix store exposes this binary command. So Tvix store daemon runs this store daemon, and then other instances of Tvix can connect to that. Tvix store mount exposes the Nix paths through fuse. So one is content address is just a bunch of blobs, you can't really do anything with it. If we run this Tvix store mount, it exposes these files just as a Nix store paths that we're used to. Tvix store copy allows us to ingest local store paths into the Tvix store. And while it's not technically part of Tvix store, Narbridge exposes Tvix store as a binary cache, just like any regular Nix binary cache. So we can upload files to it, download files from it. But on the back end, it's all this content address deduplicated storage. Okay, so let's go over a little bit more about how this deduplication works. So the Tvix CA store uses Blake3 hashing for content address blob storage. So larger blobs files are split into individual chunks, and then these chunks are content defined. So that means, say I have 2 versions of Chromium, and most of the file or the binary is the same, but a few parts of it are slightly different, then only those parts that are different, those chunks that are different, are stored separately. But everything that's the same is stored within that one chunk, since it's content defined. This is very good for storing a lot of similar data, especially in our use case at Replit. We have snapshots of Nix packages over the years, and a lot of packages don't change all that much. So instead of just having this duplicated over again, why not just store it once and define it? Okay. Another cool feature in Tvix Store, this is currently experimental, but store composition allows us to use multiple different backends for each of these nodes at the same time. So say I want a few Nix store paths that are really important to me, and I need to run those fast. I can store those on a local disk, and I still want access to a bunch of other paths not as important. I could store those in the cloud, and then Tvix Store knows how to ingest both of these together and serve. So when I'm looking into my Tvix Store, I could still see everything, even though some are slower than others. Another cool feature, we can set this up similar to like an LRU cache. So if we say everything is in the cloud, we have this local disk. As we hit store paths, let's just pull that data into our local disk. And that works pretty well. Okay, so let's go into how does Replit use Tvix Store, now that I talked about what Tvix Store is and what it does. Okay, so this is our old system for managing containers. So we have this purple is a container management VM. So Replit, we have all these containers that we serve to users. This VM manages all those containers, some custom orchestration that we do. This giant Nix cache is mounted into the VM and then mounted onto each of those containers. And then the user files, their project files, and their local Nix store is also mounted into the user container. So how does this change with Tvix? Okay, so this is a diagram of our new layout. So we have all these Tvix blobs, directory info, path info is inside the persistent disk. It's a lot smaller than our previous persistent disk since it's content addressed. We have our container manager VM. This VM is now running Tvix Store as a systemd service, and then that's mounting, exposing through Fuse the Nix local store. So we have our blobs directory path info running through the daemon, and then that exposes our Nix local store. And then to the container, this still looks like nothing changed. We're just exposing a similar Nix store, same thing, local overlay store. Works fine. Makes sense. Cool. So that is a lie. That's not how it actually works at all. Kind of. So we had to cheat a little bit since Tvix is still in active development. So for now, I mentioned before the metadata. So Nix stores metadata in like /nix/var. We have this SQLite database, has all the paths. When you do Tvix Store mount, it exposes a Fuse file system of the Nix store paths, but it doesn't have any of the metadata there. So in order to do this local overlay store, we still need the metadata. So right now what we're doing is we have the SQLite database that we generated beforehand, shove that into the persistent disk, and then read that in the local overlay store. Kind of hacky, can't do all the modular stuff we want to fix with this, but it works, and it's in production right now. Now, in the perfect world, once Tvix finishes some more stuff, the pure Tvix implementation, we would have the Tvix Store daemon. The Tvix Store mount would still expose all those Fuse paths, but then this piece, the Tvix Nix daemon, exposes a Nix daemon socket. And then we can mount that into the user container and then point the local overlay store to point at that for the metadata. And then it could query that, get all the metadata it needs from the socket, and that metadata is read directly from the Tvix Store. So we don't need to do any hacking around with SQLite databases. Okay, so what are some takeaways of what we were able to accomplish? So we were able to compress our Nix cache disk from around 6-ish terabytes of Nix store paths down to around 1.2 terabytes. For us, this reduced our cost for our disk by around 90%, so definitely a big win on our side. Also, incremental updates don't take up as much space, so it's more feasible to roll this out more often. So what's some future work we can do? So using the Tvix Nix daemon, like I mentioned, we could just query the metadata directly from Tvix Store. We don't need to have the SQLite database. Now, using store composition, if we have this Nix daemon for the metadata, now we can start using these cloud backends. We can maybe even remove the persistent disk entirely and just have the LRU cache that I mentioned before. So all this, once the Tvix Nix daemon is ready, we can do all this fun stuff. Okay, so I'm gonna do a quick demo. A lot of people who I've talked to about Tivix know kind of what it is, don't really know how to use it, don't know what to make of it. So let's switch over to the terminal and we'll do a quick demo on how to use this. Okay, cool. So here I have a couple different versions of LibreWolf from some different channels. They all have different versions. So let me Nix copy this. So I'm going to copy this into a local Nix store. So this is similar to what we had on our old persistent disk. We just copy the Nix paths into a local Nix store and then put that on disk. So let's copy that. Okay, that's copying over. Take a second, not too long because this is all local. Almost done. All right, perfect. So we have Nix store. We have all these store paths in the Nix local store. Let's check the size. Okay, 5.1 gigabytes, a few different versions of LibreWolf. Cool. So I mentioned before there's this NARBridge utility that we can use to turn Tivix into Nix binary cache. So I'm going to run that right now. So now I have a Nix binary cache hosted on my computer, and I can Nix copy stuff into that binary cache. So right now what this is doing, so copying the paths, doing all the chunking, all the deduplication, putting that into these Tivix store files. I'll show you those in a second once this is done. This is going to take a tiny bit longer since it's doing all this chunking. Almost there. And finished. Okay. So all that's copied up. If we look inside this Tivix store directory, what we have, like I mentioned before, we have this path info database, this directory database, and these blobs. And the blobs are just a bunch of little tiny bits. Let's check the size of that. So sh Tivix store. 2.2 gigabytes. Okay. So if we compare those, 2.2 gigabytes compared to the 5.1, that's pretty good. Also, I do want to note that I do have auto store optimization on, so I am saving some disk space on hard links inside the local Nix store. So if you didn't have that, it would be even worse for a Nix store. Now, if we do want to use this for anything, like I mentioned before, we have this Tivix store mount that exposes everything over a fuse file system. So if I look in this mount directory, and there we have all these Nix paths, just like the Nix local store. Great. So, and this is exactly how it works inside of Replit, inside of our backend infrastructure. We're just running this Tivix for a mount. Right now we're cheating with the SCaLE database, but eventually we won't need to do that. Okay. Great. So I would like to thank my coworkers, Ryan Mulligan and Connor Brewster. They helped me a lot along the way working on this project. I'd also like to thank Florian Klink, Floki, and all the Tivix contributors, and we're happy that Replit has been able to financially support them on working on this project. Great, so thank you so much. Does anyone have any questions? And also, Replit is hiring. Yes, Thomas. What was that? Last part? Yes. Yes. Yes, so the question was, if we copy into a compressed binary cache format, we could get some benefits from compression, not just from deduping. Yeah. And then we could do comparison with deduplication. Yeah, for sure, definitely, that's something we could look into. Yes.
The metadata database hack that you've done,
Yes.
does that just support the two-layer store only, or is it necessary for like a simple?
Yeah, so the question is the metadata layer hack that we did, is that just to support the local overlay store or just for anything? So when you use Nix to query any sort of Nix command, is going to be reading that metadata to see does that store path exist in the store. Even if the file is there, it still wants to know, like, does Nix think it's there? So if we wanted to use like Tivix just directly without any local overlay store, using this Tivix store mount, we would still need some sort of way to query that metadata, be that the hack that I did with SQLite database or using the Nix daemon. Yes. Yes, that's so. Yes, so the question was, the first time it's going to look for a lot of our info, and then after that it's going to be cached, so it doesn't need to look at it again. Yeah, that should be the case with, I mean, it just acts like a regular Nix binary cache for using that in our bridge. More questions, comments? Yes? So right now, the question was, do we have any issues cross Nix versions with the SQLite schema? So right now in Replit, we just have a pinned version of Nix that we use for everything within the container. So we're able to just account that everyone is using the same version of Nix in this, and we don't really need to worry about it too much. Yeah. All right. Great. Thank you so much, everyone.
All right, we have a few minutes until the next talk, so feel free to mill about, chat, be nerds together, whatever you want to do. All right, it's time for the next talk. This is Configurable Flakes from Ilko Dolstra.
Thank you. Can you hear me? Yeah, cool. Okay, yeah, so this is about configurable flakes. So I submitted this talk proposal and it got accepted, so then I actually had to go and implement it. But as proof that it actually works, I mean, I should say this is very work in progress and there are a lot of rough edges and certainly the design needs to be, you know, figured out completely. But yeah, it works. So I'll give a quick demo and then talk a bit more about the details. But yeah, so the goal is to make flakes configurable. So up to now, as you know, flakes are fully hermetic, so you can do things with them, like build them, but you can't pass any configuration flags to them on the command line. So, and now you can. So here I have a little flake, a flake.nix. Now, what we could always do is have something like nix build, and this produces a small package, so it was already built, which is why it was so fast, and that prints hello world. Now, but I want this thing to be configurable, so I wanted to have some options like who to greet. Now, in the pre-flake world, you could do something like nix build, and then you could pass an argument like this, --arg. The problem with that was undiscoverable. So to figure out what sort of function arguments you could pass, you either had to read the source code or you had to read the documentation if it existed or go to a wiki, whatever. So that was bad. And also it breaks hermetic evaluation. So now, however, so Flakes didn't allow that up to now. So what you can now do is well, the important thing is it should be discoverable. So I have this thing, I can do a nix flake show, and it now shows a configurable package. So that is a package that has some configuration options, and if I want to know what those options are, there is a new command, nix describe, that shows you information about a flake output. And this shows what the options are. So it has things like who. An option who with type string, so this is typed, and yeah, let's see what we can do with that. So I can now do nix run, so that's equivalent to just doing nix build and running symlink, and I can do something like pass a string argument, and who, well, who are we going to greet? Pass, well, no, we're going to greet planet nix, of course. So that's going to build. Maybe I should have gone for something that is cached. Oh, no, something is happening. I'm giving it 3 more seconds. 3, 2, 1. No, I'm killing it. We're going with Pasadena. Okay, hello Pasadena. Okay, so that works. Now, there's another option here. That's a Boolean option, big. Well, let's try that. Enable big. Ah, awesome. So very colorful. Now another thing you can do is you can pass flake outputs to other flakes, which is important because it enables things like plugins. So I can do, so we saw over here there's an option printer, the package used to print the greeting. So let's do that. So --with printer, let's say nix packages. Now, unfortunately, ponies say I don't have that locally. I think that's going to download, so I'm going with cow say. And there we go. So now we have that. And so this is all fully cached. Now, another cool thing is that, yeah, I mentioned this, you can have plugins. So I can do something like nix build nix packages, and I want to build the dwarf fs package. Now you may know that's actually not in nix packages, which is a bummer, but I modified nix packages to have an overlays option. So now I can do --plugin overlays, and now I could do something like GitHub /dwarffs, and I'm going to give it the overlay. I mean, this should be kind of automatic, but Okay, and now it's going to build. So I've extended Nix packages with an overlay. So this means you can now have, say, flakes that only export an overlay, which usually wouldn't be usable in itself. The only thing you could do with a flake like that is plug it into another flake to sort of instantiate it in a version of Nix packages, which is very cumbersome. But now you can just do it from the command line. Okay, so that was the quick demo. That was really my talk, but I'll go into a bit more detail. Yeah, so why do we care about this? So yeah, flakes are important. They're very popular. The vast majority of projects these days uses flakes. That's the big red line at the top on GitHub. So a very quick primer about what flakes are. Flakes, the goal is to fix these problems that we had with the pre-flake world, where there was no standardized way of distributing Nix artifacts. So you could have a Git repository, you could have say a file like default.nix in it, but that wasn't standardized. How you would build that thing wasn't standardized. Those projects typically had dependencies on other Nix-based projects like Nix packages. Almost anything depends on Nix packages. But how you manage that dependency, well, that wasn't standardized. You could use the Nix path environment variable, or you could use fetch tarball. But yeah, it was all very ad hoc. And it wasn't hermetic. So Nix kind of introduced that, or the concept of reproducible builds, but Nix evaluation wasn't very reproducible at all. So yeah, flakes try to solve that problem. So a flake is just usually a Git repository with a file called flake.nix in it, and the contents of that file is essentially an arbitrary collection of Nix artifacts. So that can be derivations or NixOS modules or Nix packages overlays or Hydra jobs, whatever you want. So the flake standard doesn't dictate what you can do with it. And flakes can have dependencies on other flakes. So those are the inputs, and those get locked automatically by Nix in a lock file, just like you would expect from a modern package manager. So there were a couple of design goals with flakes. Let's see if we met them. So one was reproducibility. So hey, we always want a operation like a build on a flake to produce the same evaluation result. So that's why we have hermetic evaluation, and that's why you cannot just pass in arbitrary environment variables or command line flags. So yeah, that works. It's composable because yeah, you can have dependencies on other flakes. It's extensible because we don't care what you put into a flake.nix. A very important one is the just works aspect. So you want to be able to point a command like nix run at an arbitrary repository on GitHub, and if it has a package in it, it should just work. So you shouldn't be required to first read the README of that project and figure out what command lines or flags or environment variables you need to set. So yeah, that's a very important property. It should be discoverable. So again, you shouldn't be required to consult the documentation or read the source code to figure out what you can do with a flake. You should be able to do something like nix flake show, and it will tell you what's in a particular flake. Yeah, so the missing one is configurability, because that one is kind of in tension with some of the other goals. We do want users to be able to configure flakes on the command line, and this is one of the most requested features for flakes, in addition to lazy trees. So yeah, flakes are not configurable. Like I said, in the before times, you could just pass command line arguments, and yeah, with flakes you cannot do that. So why don't we just do that? Why don't you just allow you to pass --arg to a flake? That would be the path of least resistance. Just add a options argument to the outputs function of a flake, and problem solved. And that would be very easy. But That's not discoverable, so we would be back in the bad old days where you need to read the source code to figure out how you can configure a project. It's not type checked, so if the thing that you pass is not the right type, then it will probably fail with unfriendly error messages. It breaks the just works property because, again, you now need to consult the documentation or read the source code to figure out how to make something work. And it complicates evaluation caching, so we need to figure out how to do that. Okay, so the challenge is make flakes configurable while still maintaining discoverability. So the solution is controlled configurability. So flakes should explicitly declare what configuration options they support. Those should be typed, and if you don't declare a configuration option, then it doesn't exist and you cannot pass it as a user. So here's an example of the Hello World flake that I just used. So it has a new output type called configurable packages. Now Nix actually doesn't know anything about the configurable packages output type because, as we shall see, this uses something called flake schemas. So we don't need to build in support for that into Nix itself. This is not specific to configurable packages. Any flake output type could be made configurable. So if you want to make something like NixOS configurations configurable from the command line, you just need to write a bit of glue code that tells Nix what the configuration options are, which it could get from the NixOS module system, or whatever else you want to do. Okay, so what this does is, it declares the options that this flake output has. So it has a who field, which is of type string. It has another thing of type Boolean. We don't want to come up with a type system for Nix because that would be a big research problem, and that's never going to work. Sort of the meta type system is here. A type is exactly like in NixOS. It's just an attribute set with a description in it and a field called check, which is a function that checks whether a value is an inhabitant of that type. So you can use the NixOS type system for that, but you can do whatever you want. It's duck type, so you just have a .check function, and that's really all there is to it. Okay, and its options need to have descriptions because we want it to be discoverable. So you cannot get away with not providing a description. Now finally, we need to tell Nix how to actually do something with those options. So this thing has a function called apply options, which takes the options from the user, and in this particular case, it generates a derivation that prints hello world. But it can do whatever it wants. So it doesn't have to be a package. It could be a NixOS module or some arbitrary value, whatever you want. Okay, so a few words about how this is implemented. So like I said, this should be a generic mechanism. We don't want to do this specifically for things like packages, and we don't want to have a type system. Previously, I worked on something called flake schemas, which are a way to factor out all the built-in knowledge that Nix has about certain flake output types, because that's very ugly. So what flake schemas do, they get rid of all this C++ code. So a command like nix flake check in Nix previously had a lot of specific knowledge about how to check something like Hydra jobs or packages, which means that if you come up with your own flake output type, nix flake check won't be able to check it for you, nix flake show won't be able to show it. So that's very ugly. So flake schemas allow us to get rid of all that code. It's always nice if you have a lot of red in a pull request. Yeah, so that's what flake schemas do. So previously, flake schemas just exposed information about the contents of a flake output. So for instance, the schema for the packages flake output type would just enumerate all the packages that you have in a flake, plus some other metadata. So this just extends that by exposing what the options are of that flake output and how to actually apply those options. So here is the schema of configurable packages. So it's fairly short. So first there's some metadata, which can be used to generate documentation for a flake. Then it has some information about what commands operate on this. This is a new feature in flake schemas, but since Nix shouldn't have any built-in knowledge about flake output types, for example, the Nix build command needs to know which flake output types it's supposed to try to build by default. So here we're saying a configurable package is something that Nix build should try to build. So if you omit configurable packages dot blah blah, Nix build will try to build it for you. Now finally there's a function called inventory that enumerates what the packages are in your flake. It returns some metadata about this, that this is a package. And then the important thing is it returns the options. Now in this case, the options are provided by that package. But if this was something like a NixOS configuration, this would use the NixOS module system to extract the options, to expose them to the Nix CLI in a way that the Nix CLI doesn't have to know anything about the NixOS module system. And then finally, we need a function that actually applies the options. So it will take the options provided by the user, and in this case, yeah, that's trivial because there's already a function that does that. But again, for something like the NixOS module system, it would do something slightly more complicated. Yeah, how am I doing on time? Let me check. Okay, pretty good actually. Yeah, so implementation. So an important property is we need to preserve evaluation caching. So that's what makes sure that if you do something like a Nix build twice, the second time is going to be very fast because it has cached the result of the evaluation. So in this case, we need to calculate a hash over the user options and make that part of the cache key. Yeah, then we check that every option has a matching declaration. So if you try to pass an option that isn't explicitly declared by the flake, you'll get an error message. We call the check function on every option. And then finally, we call the apply options function to get the actual result of the flake output. So yeah, that's pretty straightforward. Yeah, I already showed the plugins, so that's just another type of option. So one example of that is I made a little wrapper flake for Comfy UI, which is this stable diffusion user interface. So you can use that to run stable diffusion models. Now the state of the art of configuration management in the AI world just seems to be to download files and put them in random directories and you iterate until it works. So that's kind of annoying. So if you run something like this, you're quickly going to find out that you don't have to write models, and then you have to go chase them down and put them in the right directories. So it would be much nicer if you could just configure that in a more declarative way. So this Comfy UI flake has a bunch of configuration options like checkpoints, which are the base models. So that's a list of packages. It has LoRa's, which are adaptations of those models, for instance, to implement a certain style. So yeah, you can then do something like, you can do something like this. You can run the Config flake, and you can pass checkpoints. You can pass another flake output, Config hash checkpoints dot stable diffusion, etc., and so on. And if you pass something of the wrong type, you'll get an error message. And the nice thing about this is that because Nix now knows about the types of these things, you could do something nice, like something like search.nixos.org, or FlakeHub could, present you with all the flakes and flake outputs in the known universe that implement the declared types. So that makes things much more discoverable. So yeah, now if you run this command, you get a Config instance that works. Okay. Now I use the word declarative, but of course I see some of you angrily looking. This is not declarative at all. This is super imperative. So what you actually want to do is, the imperative workflow is nice because you can tell users, if you just want to get this package to work with these options, just type in this command. You don't have to learn the Nix expression language, which is hard. But ultimately, you want to put this under version management control and share it with team members, etc. There's a command for that. It takes a imperative invocation, so all these option flags, and turns it into a flake. So you can say Nix flake, new from configuration. You give it the flake that you're sort of instantiating from, and a directory where it should put the flake. You can give it a bunch of options. And that will generate a flake for you, and then if you run that flake, it does what you expect it to do. So yeah, just don't look at the implementation because right now the semantics are super shady. But, okay, a couple of to-dos. So right now you can only pass flake options at the flake output level. You probably also want to be able to have options at the top level, so to configure an entire flake. I didn't do that right now because that would require changing the actual flake interface a bit. We would have to add a function argument for that. But yeah, that's probably something that we would want to do. And another thing is kind of related to the previous slide. So this currently generates a flake.nix, but probably what you want for a configuration flake is something with a simpler syntax, like JSON or TOML, because these are just name-value pairs that set configuration options. You don't need the full complexity of the Nix language for that. And you could imagine, given the notorious complexity of the Nix language, in organizations there are often some people who are capable of writing Nix and everybody else isn't. What you can then do is you can have the Nix experts, they can make a configurable flake, and then everybody else can just instantiate those flakes without actually having to deal with the Nix language. But I haven't implemented that. Okay, conclusion. So we now have discoverable flake configurability, with the emphasis being on it being discoverable. This extends flake schemas. And if you want to try it out, there's some magic commands there. That's it. Any questions? Oh, sorry. Yeah, I didn't see.
The use case for this is sort of name value passed from the command line. What's the reason for the type system in the configuration? Why do you have to specify a string? Are there use cases beyond that you're anticipating?
So that's one of the things that probably should be different. Because we can get the type from the option declaration, so probably you should just be able to say -- option or something like that. I'm not entirely convinced. It seems also kind of nice to require the user to actually specify the type so that you are sort of asserting this is what I expect the type to be, and then I mean if there's a mismatch you'll get an error message. So I mean if we had generic options, then we have to coerce them into the right type, which I mean yeah I don't know what the best thing to do there is. Yeah. Yeah. I mean, flakes were definitely intended to replace the old channel mechanism because channels were really just a copy of the source code plus a pointer to a binary cache, if I remember correctly. And I mean, it's just more convenient to just point to the actual source code. But yeah. So I mean, yeah, I think channels are definitely a kind of deprecated mechanism. Anybody else? Yeah. I think, at least for log files, one thing we want to do is make log files sparse. So right now, log files copy all the transitive logs, which means that log files have a tendency to kind of explode in size. So that's one evolution of the log file format that I think we should do. Yeah, so I mean, we've always tried to avoid having version constraints in Nix itself. I mean, so for example, in Nix packages, we don't do that. We don't have, say, a set solver that tries to find the correct versions for you. With FlakeUp, we have a mechanism to specify has semver constraints, so you can say, give me a flake that is at least version 2.3, etc. But other than that, yeah, flakes themselves don't have a versioning mechanism. Maybe they should, but right now it's really, yeah, if you want version constraints, you should just add an assert. And that can be pretty limiting because, yeah, if you get really a flake-based ecosystem, right now Nix doesn't have a way to find a satisfying set of flakes for you. Yeah. All right, thank you.
Hello, hello. Real quick, before anybody takes off or anything like that, so in this room, we're about to do the Unconference, but we also wanted to get that photo that Ron mentioned earlier. So nobody leave unless you don't want to be in the photo. We're going to get all the photo stuff taken care of real quick, and then we'll get the Unconference stuff going. So everybody kind of sit tight for just a second. All right. So, all right, listen up, listen up, listen up. Yeah. All right. So we're not going to do the photo because people have already started leaving, but we are going to do the unconference right now. So what I need is there's a whiteboard right outside one of these doors. I forget which one now. Somebody wheel that in and bring it up front. That would be a big help. Everybody else, if there's a topic that you want to talk about, come on up front, and we're going to start kind of getting things on the whiteboard as soon as it's up here. All right? All right. Nobody knows where the whiteboard markers are. So instead of doing this on the whiteboard, everybody, hello. All right. So rather than using the whiteboard, we have some printer paper up here because nobody knows where the whiteboard markers are, despite the fact that there is stuff written on the whiteboards. Don't know how that works. I have a pin up here. This doesn't belong to me, and I have been told that if I lose it, I will be fired. So do not take it, please. Yeah, this belongs to our CTO. If you have a topic that you want to talk about, come right on the paper here. We're going to do this for a few minutes because the other talk is still wrapping up. So I want to give those folks a chance to chime in, bring up any topics they want as well. So we're going to do this for probably another 10 minutes, and then we'll finally get things started. So let's just go ahead and get that started. All right, folks, it's time to get started. So we have a very short list of topics that that anybody has written up here. 2 of them are from me. So there's got to be stuff that you want to talk about. Come write it up here. And then once you do that, I'll give you 2 minutes to do that, and we'll actually start voting and break off into groups. All right, we're going to vote by show of hands. There's a list of 6 topics here. You can raise your hand twice. So I'm going to read them out first, and then you can vote. The first one is larger scale Nix/NixOS deployments. That's number 1. Number 2 is what do you want from a Nix conference? Number 3 is debugging Nix expressions. Number 4 is NixOS and a word that I don't know how to read. It is STIG. Okay, NixOS STIGs. I don't know what that is, so maybe you can explain that in a second. Home free, modular self-hosting, and the last one is lazy trees for flakes. Okay, so STIG, what is that? Security Technical Implementation Guide. God. Okay. Okay, so you get to vote twice. Vote by raising your hand. So if you want to do larger scale Nix/NixOS deployments, raise your hand now. Okay, I'm just going this off of vibes. That looks like roughly half the people here. What do you want from a Nix conference? Raise your hand. Nobody. Cool. Next. Debugging Nix expressions. Wow. Okay. Cool. I'm just writing some of these down. NixOS STIGs. Probably not happening. Home free, modular self-hosting. Weak support. Okay. Lazy trees for flakes. Okay. So here's what we'll do. First, we're going to break off into larger scale NixOS deployments and debugging Nix expressions. So let's do the larger scale NixOS deployments in the back and then debugging in the front. And then we'll just talk as long as we feel like it.